Good afternoon to everyone. I welcome you all for the sixth day of our FDP titled Innovations in Additive Manufacturing for Green and Sustainable Future. Now, the session 11 will be delivered by Dr. Cyril Joseph Danny. I kindly request the expert to start the session 11.
Okay, thank you, Professor. Are you able to see my screen?
Yes, sir.
Okay. Very good afternoon, everyone. Today we are going to see about sustainability in friction-based additive manufacturing. In the past few days, we have already seen a lot about additive manufacturing, so I will not go too deep into that again. But before we move into the main topic, let me quickly give you a brief introduction about additive manufacturing. Additive manufacturing, we all know additive manufacturing is a method of making components layer by layer from a digital design to final product. Unlike traditional methods where material is cut or removed, here we only use required material to build the part. This makes it very useful for reducing waste and creating complex shapes. It is already being applied in industries like aerospace, automotive, and various fields. Now, with the short background, let us move into our main focus: how additive manufacturing contributes to sustainability. So let's get into the content of this presentation. These are the contents for today's presentation. In this presentation, I'll be discussing importance of sustainability in manufacturing and how additive manufacturing contributes to it. I will then move on to the key dimensions of sustainable additive manufacturing, highlighting the different aspects we need to consider when we talk about sustainability. Next, I will explain the differences in sustainability goals between fusion-based and friction-based additive manufacturing. After that, we will look into the benefits of sustainability in additive manufacturing processes, supported by practical examples as well as the challenges faced during implementation. All these topics will be covered in detail in the following slides. So, sustainability in manufacturing means producing good in a way that meets today's needs without harming the environment, exhausting natural resources, or reducing the ability of future generation to meet their needs. In other words, it is about balancing three key factors. The first one is environmental sustainability, where we have to reducing waste, saving energy, cutting emissions, and using eco-friendly materials. And second one is economic sustainability, making sure the process is cost effective, efficient, and supports long-term growth. And the third one is social sustainability, where we have to ensure the safety, health, and well-being of workers and communities. So in manufacturing, sustainability can be achieved through practices like using less raw material and energy, recycling or reusing by products and waste, designing products that last longer and can be easily repaired, and shifting towards cleaner technologies like additive manufacturing. Additive manufacturing connects well with this sustainability in many ways. It reduces waste because only the required amount of material is used, and it can make lighter products, which helps reduce fuel use in cars and planes. It allows on-demand production, so we don't need to store or ship large quantities. In some cases, leftover powders or materials can be recycled and reused in additive manufacturing. Still, there are challenges in additive manufacturing. Some AM processes use a lot of energy, and recycling all material is not that easy. But as the technology improves, additive manufacturing has strong potential to make manufacturing more eco-friendly and sustainable. So these are the key dimensions of sustainable additive manufacturing ecosystem. Sustainability in additive manufacturing is not limited to energy efficiency. It involves a notable balance of society, economy, environment, and safety. From a society perspective, additive manufacturing ensures improved product quality, design freedom, and ethical manufacturing practices. For instance, medical implants made using additive manufacturing provide personalized solution that enhance patient quality of life while reducing the need for resource-heavy conventional machining. In terms of economic dimensions, additive manufacturing improves productivity by reducing lead times and tooling requirements. For example, aerospace industries use additive manufacturing to manufacture complex turbine blades and lightweight components, reducing both production cost and fuel consumption during service. The environmental dimensions focuses on reducing energy consumption, minimizing emissions, and improving recyclability. Powder bed fusion, for instance, allows unused powder to be recycled, whereas friction-based additive manufacturing consumes far less energy by avoiding melting altogether, making it more greener. Lastly, safety aspects cover reduced waste, operator risk, and health hazards. For example, fusion-based additive manufacturing processes like laser melting generate fumes and UV radiation, whereas in friction stir additive manufacturing, that is solid-state additive manufacturing, operates at solid-state condition, eliminating harmful emission and making the workplace safer. Together, these four pillars create a sustainable framework where additive manufacturing not only enhances manufacturing efficiency but also ensures long-term social and environmental well-being. Here, I have summarized several advantages of additive manufacturing that contribute to sustainability and operational efficiency. One of its key strengths is material efficiency, as it uses only the necessary amount of material for each build, dramatically reducing scrap and mitigating landfill waste. Another significant benefit is energy reduction. Additive process require less energy for small batch production, rapid prototyping, and custom parts, making them far more efficient than conventional manufacturing for these applications. The technology also enables supply chain simplification by supporting local on-demand production, which not only lowers transport emissions but also helps avoid the accumulation of excess inventory. Furthermore, additive manufacturing empowers design optimization, allowing for the creation of lightweight, intricate geometries that can reduce energy consumption during the product's operational life. Finally, waste minimization is achieved through decreased reliance on support structures and reduction in leftover material, setting additive manufacturing apart from traditional process and further supporting its status as a sustainable manufacturing solution. So, when we comparing fusion-based additive manufacturing with friction-based additive manufacturing, while fusion additive manufacturing provides significant advantages over conventional manufacturing, there remains considerable potential for improving its sustainability. To address these challenges, friction-based additive manufacturing emerges as an excellent alternative for the industry. Friction-based methods have demonstrated superior sustainability performance across several key aspects, including raw material selection, equipment efficiency, and lower energy requirements. They also excel at minimizing material wastage, enhancing reusability, and reducing overall material costs. Importantly, friction-based processes generate fewer emissions such as fume and toxic gases, which contributing to a safer and cleaner working environment. Additional advantages include shorter processing times, simpler and less costly post-processing needs, and greater flexibility in production size, accommodating both high and low volume manufacturing with high deposition rate. In the following sections, we will explore each of these sustainability aspects in detail. The first one is raw material selection. Powder handling and automation in fusion additive manufacturing drive higher emissions than in solid state additive manufacturing, mainly due to the energy intensive nature of producing raw metal powders in additive manufacturing, fusion additive manufacturing. Fusion additive manufacturing relies on high energy automation processes such as gas or plasma automation to convert metal ingots into fine powders. These steps consumes large amount of energy because automation uses high temperature to melt metal and then rapidly cool droplets into powder form, which requires significant higher energy input. So production of inert gases such as argon used in automation process, which is energy intensive and contributes substantially to CO2 emissions. Powder handling involves complex steps to maintain purity and safety, including enclosed systems, humidity and oxygen controls, and repeated sieving, adding to energy use. In contrast, solid state additive manufacturing often bypasses the need for optimized powders. Instead, they are using bulk and mechanically derived feedstocks at lower temperatures, which drastically reduces the energy consumed for powder preparation and handling. This eliminates many emissions associated with powder production and processing in fusion additive manufacturing methods. When it comes to additive manufacturing equipment, when comparing sustainability between fusion-based and friction-based additive manufacturing equipment, important differences become clear. Fusion additive manufacturing equipment such as laser powder bed fusion, that is LPBF, or electron beam melting EBM, SLM, whatever you name it, all the system requires very high energy to melt metal powders, and also depends on supporting system like inner gas chambers, vacuum environment, and cooling units. For example, producing titanium powder for LPBF through gas atomization is extremely energy intensive and generates significant carbon footprint. And also, these fusion-based additive manufacturing equipment involves a higher amount of initial cost when compared to friction-based additive manufacturing equipment. On the other hand, friction-based additive manufacturing equipment such as friction stir additive manufacturing (FSAM) and additive friction stir deposition, something like friction surfacing method, uses frictional heat and pressure without melting the material. This means the process consumes far less energy and often works in open atmosphere without the need for costly vacuum or shielding gases setup. In addition, friction-based AM can directly use bulk rod plates or even recycle machine chips as a feedstock. For instance, aluminum or magnesium chips from machining can be consolidated into new components using additive friction stir deposition, avoiding both waste and extra powder production steps. Overall, friction-based additive manufacturing equipment provide a more sustainable approach, offering lower energy use, simpler systems, and better resource efficiency compared to fusion-based systems. When we are seeing energy requirements for additive manufacturing, the energy requirement in additive manufacturing varies significantly between fusion-based and friction-based processes. Fusion-based additive manufacturing methods such as laser powder and VAM and EBM demands very high energy to completely melt metal powders, often at temperatures above something like 1500 degrees Celsius. In addition to the melting process, extra energy is consumed by laser or electron beams and vacuum pumps, inner gas system, and cooling units. Those are making fusion AM highly energy intensive. So, in contrast, friction-based additive manufacturing processes like friction stir additive and friction surfacing additive operate in the solid state. Here, material is softened by frictional heat and the mechanical pressure instead of being fully melted. So, this drastically lowers the overall energy demand since only mechanical input is required. For example, friction surface deposition can directly use aluminum rods or even recycle chips to build new parts with far less energy compared to powder-based or fusion methods. Thus, friction-based additive manufacturing provides a more sustainable pathway with reduced energy consumption and lower environmental impact. So, the difference between material wastage and reusability difference between fusion versus friction. Fusion-based AM, the material wastage starts from the powder production itself. Fusion processes commonly faces challenge with material wastage due to the nature of the process and safety concern in recycling. During powder production and handling itself, a considerable amount of material is lost through sieving, overspray, or contamination. Even within the build chamber, not all the powders is consumed. For instance, in powder bed fusion, only about 20% of the metal powder might be used for build, while the remaining 80% theoretically could be recycled. Contamination risks and safety standards often force manufacturers to discard significant amount of reusable material. in sectors producing safety critical parts like aerospace and healthcare. Even minor contamination leads to the rejection of entire batches of powder, driving up waste and cost. However, advanced solution like closed loop powder analysis, that is powder cleanser, are emerging, which now allow manufacturers to confidently recycle powders on the production floor, thus improving the reusability and reducing overall environmental impact. However, these analytical methods are further increases the overall cost. In contrast, friction-based additive manufacturing operates differently, resulting in dramatically lower material wastage and improved reusability. Since these processes avoid high temperatures, melting, and vaporization, there is a minimal risk of powder contamination and any other oxidation contamination. And almost all unused feedstock and scrap from the build can be directly recycled without extensive post-processing. For example, friction strip process enable the reuse of metallic shavings and scraps to fabricate new components, promoting a truly circular economy in metalworking environments. This makes friction-based additive manufacturing highly desirable for industries focused on sustainability, material efficiency, and green manufacturing strategies. These examples show that while fusion additive manufacturing can be efficient, that relates of safety and contamination create notable barriers to material reusability and resource conservation, whereas friction-based approaches offers a cleaner and more sustainable path forward for many applications. When it comes to emission, emission is the one of the crucial thing in fusion-based additive manufacturing. So, fusion additive manufacturing produces a range of toxic fumes and gases during the melting process, which can pose health and environmental risks if not properly managed. Key toxic substances in these fumes include chromium 6, that is hexavalent chromium, and zinc and manganese oxides, as well as nickel and chromium and cobalt oxides. These are posing serious health concerns for humans. Hexavalent chromium is well-known carcinogenic and respiratory irritant, while zinc and manganese fumes can cause metal fume fever and neurological effects, respectively. These metal fumes and ultrafine particles are generated particularly during powder bed fusion and direct energy deposition processes, making inhalation exposure a serious occupational hazard. When we talk about particulate matter in metal fumes, there are two main types of particles. First one is inhalable particles, which are a very few microns in size, and a second one is respirable particle, which are at the nanoscale. Most metal fumes generated from welding and or additive manufacturing consist primarily of respirable particles. These, which are in nano size, these tiny particles can penetrate deep into the human lung system. So, prolonged exposure to such respirable metal fumes possesses serious risks, leading to significant respiratory health issues over time. So, the fumes requires specialized ventilation, filtration, and proper exposure controls to protect workers and reduce environmental contamination. However, processes like laser beam powder fusion (LBPF) and SLM operate within the closed or vacuum environments, which helps contain and significantly reduce the release of such hazardous fumes. But in contrast, wire arc additive manufacturing often utilize large-scale production involves extensive melting and solidification in open or semi-enclosed environments. This leads to the generation of high volume of fume which containing these toxic metals, increasing the challenge of controlling emissions and necessitating robust ventilation and filtration systems. In comparison, friction additive manufacturing process such as friction stir based or friction surfacing based avoid high temperature melting, therefore substantially limit the production of toxic fumes and gases, presenting a clear and safer alternative with reduced environmental and health impacts. So understanding these emission differences is crucial for selecting appropriate AM technologies in sustainable and health conscious manufacturing environments. So When we talk about processing time, fusion and friction-based additive manufacturing differ notably in their processing times due to their underlying technologies and operational mechanisms. Fusion additive manufacturing process like LBPF, SLM, WAM typically involve layer melting of fine metal powders, which necessitates precise control of laser paths, powder spreading, and cooling times. This detailed procedure results in relatively longer processing times, especially for complex or large parts, where multiple layers must be sequentially built and solidified. On the other hand, friction-based additive manufacturing operates through a solid state process that plastically deforms and consolidates bulk material without melting. This process generates heat through mechanical friction, allowing for faster deposition rates and reduced cooling cycles. Friction AM can achieve significantly higher build speeds and is well suited for fabricating large components more efficiently because it bypasses the need for laser scanning and powder handling. However, fusion additive manufacturing offers superior resolution and the ability to create highly intricate geometries, though often at a high cost of increased time. Overall, friction-based additive manufacturing tends to have a shorter processing times compared to fusion-based additive manufacturing for parts of similar size, making it advantageous in application where speed and material efficiency are prioritized. So, when we see the post-processing requirements, fusion-based additive manufacturing typically requires extensive post-processing due to the nature of melting and solidification involved in the process. So, key post-processing steps often include removal of support structure, which consumes a lot of raw material, and also it requires more time to remove those support structures. Heat treatment such as hot isostatic pressing (HIP) to relieve residual stresses and improve density, machining for dimensional accuracy, and surface finishing to achieve desired aesthetics and functionality. So these steps are crucial to address issues like porosity, residual stresses, and surface roughness, all those things, but they add significant time and cost to the production cycle. Whereas in friction-based additive manufacturing operates as a solid state process that plastically deforms material through mechanical friction without melting. So this fundamentally reduces defects such as porosity and residual stresses, thereby minimizing or often eliminating the need for heat treatments like hot isostatic pressing. While surface finishing and minor machining may still be necessary, the overall post-processing requirements are considerably lower compared to the fusion-based methods. The reduced post-processing not only shorten production time but also lowers the energy consumption and operational cost. Okay, so consequently, friction-based additive manufacturing offers a more efficient and cost-effective solution for applications where high mechanical integrity and faster throughput are prioritized. So, when we look into the production size, fusion-based additive manufacturing typically has limitation on production size due to the constraints of build chambers and powder handling systems. So these processes such as LBPF or SLM are optimized for producing smaller and more intricate parts with high resolution. The need for control, atmosphere, and delicate handling of these fine powders restricts the maximum dimensions that can be produced economically and reliably. In contrast, friction-based additive manufacturing, notably technique like friction surfacing additive manufacturing, operate as a solid state process without requiring control environment or melting. So this allows for manufacturing of much larger components, including full-scale aerospace, automotive, and heavy engineering parts. The open processing environment combined with high deposition rate makes friction-based additive manufacturing ideal for large volume builds. Additionally, friction-based additive manufacturing can process a broader range of materials, including dissimilar metals and metal matrix composites, which is often challenging for fusion methods. Overall, while fusion additive manufacturing excels in producing complex, detailed components on smaller scale, friction-based additive manufacturing offers significantly greater flexibility in production size and scalability, making it a preferred choice for industrial application demanding large, structurally robust parts with superior mechanical properties. So carbon footprint in manufacturing, carbon footprint is one of the crucial thing when it comes to manufacturing or anything additive manufacturing or conventional manufacturing. The manufacturing industry is a major contributor to global carbon emissions, responsible for about 1/5 of worldwide greenhouse gases and consuming around 54% of world's total energy resources. So most of this carbon footprint arises from burning fossil fuels to generate heat and electricity used in manufacturing processes, along with emissions from chemical reactions during productions, especially in sectors like chemical refining, cement, steel, and metals. Within a typical manufacturing facility, carbon emissions are classified into direct emissions from on-site fuel combustion and industrial process, and indirect emissions from purchased electricity, heat, and upstream supply chain activities. In this aspect, the solid-state additive process is most beneficial in terms of carbon emission reduction. For example, the largest CO2 reductions in solid-state additive manufacturing compared to fusion-based additive manufacturing are primarily observed across several key life cycle stages. In material production, solid-state that is friction-based additive manufacturing uses process that consume less energy to produce feedstock material, resulting in considerably lower CO2 emission than fusion methods, which rely on high demand powder production. During the printing phase, that is building phase, friction-based additive manufacturing, lower temperature, lower energy processing significantly reduces CO2 emission compared to the intense energy required for melting in fusion additive manufacturing. Additionally, friction-based additive manufacturing demands less extensive post-processing, such as support removal and heat treatment, further contributing to CO2 savings. Overall, the most substantial CO2 reduction stem from the material production and printing phase, where friction-based additive manufacturing, lower energy intensity, and simpler processing requirement provide a clear environmental advantages over fusion-based additive manufacturing. So, future directions and research. In conclusion, this presentation highlights the critical role of sustainability in advancing additive manufacturing technologies, emphasizing the clear advantages of friction-based additive manufacturing over traditional fusion-based methods. While fusion additive manufacturing has transformed manufacturing with its precision and design freedom, it still faces sustainability challenges such as high energy consumption, material waste, hazardous emission, complex equipment, and extensive post-processing requirements. Friction-based additive manufacturing offers a promising sustainable alternative by using lower energy, simpler equipment, bulk feedstock with near zero wastage, reduced toxic emission, faster processing, and minimal post-processing. It also enables the production of large parts with greater material versatility, making it suitable for diverse industrial application. To fully realize the potential of sustainable additive manufacturing, ongoing research and innovation must focus on developing more energy efficient feedstock production, recyclable materials, design automation for sustainability aspect, and smarter supply chain management. So collaboration across industries and adoption of life cycle based standards will further drive transparency and sustainability improvements. Ultimately, friction based additive manufacturing presents a pathway for manufacturing industry to achieve a balanced ecosystem that delivers economic viability, environmental protection, social responsibility, and safer working conditions paving the way for more sustainable future in manufacturing. So that's all for today's presentation. Thank you for your passion and thanks for listening. Any question? Any questions from the audience? Are you able to hear me? Any questions from the audience, Professor?
The participants are requested to clarify your doubts.
Professor, any question from the audience? You can dictate, I will answer.
I think no questions asked from participants' side.
So after this, we shall wind up the presentation. We can move on to the next session. If any question is there from the audience, you can send it to my email. I will get back to you.
A sincere thanks to Dr. Cyril Joseph Daniel for spending his valuable time with us. Thank you, sir.
Thank you. Thank you, Professor.
So we will move to session 12, which will be delivered by Dr. Sabrinath. Good afternoon to all. The session 12 will be delivered by Dr. Sabrinathan Pandiyappa. Good afternoon, sir.
Good afternoon, sir.
He is having lot of experience in the fabrication of composites and testing composites 3D printing. So the research scholars, we can ask your doubts regarding to the research on the composite 3D printing. Now I request Dr. Sabrinathan to start the session 12.
Thank you so much, sir, for this opportunity for sharing research ideas in this kind of research platform. Okay, for the last session, I have discussed a lot of things related to basics. So this session, I will try to cover mostly related to composite 3D printing, how to make composite filaments, how to print composite filaments, and what are the challenges you are going to face during composite printing, and how to use those components in various kind of biomedical application, healthcare sectors, and making implants. And like that, I am going to discuss more about related to healthcare sectors, because currently I am working related to healthcare sector. So I will share my screen first, then I will go to. Is my slides are visible?
Yes, sir, visible.
What about my voice? Voice audible?
Yes.
Okay, thank you so much. So I'll start my session. So today's session, I'm going to concentrate more on composite 3D printing advancement, and also I'm going to discuss more about healthcare applications. So I don't want to introduce myself. So today's session, most of the topic related to medical 3D printing and need of medical 3D printing. And I don't want to go again. Don't want to go about different types of additive manufacturing classification and all. So I just give the basic intro related to application and perspectives. Then I will go to mostly related to composite 3D printing. Then applications where you are going to use these kind of composites, and the challenges and limitation, and what are the things we have published till now using composite 3D printing, and what are the works in process related to composite 3D printing, as well as implant developments. These are the things I am going to discuss today's session. Towards composite 3D printing, there are a lot of 3D printing processes there. Among that, I am going to discuss more related to material jetting, which is closely related to polyjet, then material extrusion. There I am going to discuss more about how to make composites for various kind of implant development. For material jetting, which is polyjet, which is related to cadaver kind of things. So I will discuss more about in the upcoming slides. In material extrusion, they are using 3 different types of materials. I have already discussed those things, which is first one, which is filaments, then pellet, then the final one, which is ink. In powder bed fusion, they are using powder as a source material. In material jetting, they are using photosensitive resin. The difference between wet photopolymerization and material jetting is the simplest difference is in wet photopolymerization, the laser source will come out of the bottom and the resin will be in the tank. But in the case of material jetting, the resin will be sprayed as a like a spherical in shape, and they are sprayed into the print bed. This is the main difference. Coming to the application, there are a lot of applications are there. When you are making composites, now you need to know what composite you are going to do. Okay, if you are using ink-based printer or else clay-based printer, now you can make ceramic composites. Not only polymer composite, you can use ceramic composites also. In case of you are using extrusion kind of things, now in extrusion the extrusion is a generic term. In extrusion only, you are going to use polymer. Similar to metal also it comes the VAM, which are also similar to the extrusion process only. Okay, so coming to the application perspective, in biomedical there are a lot of scopes related to 3D printing. So I will discuss more in the upcoming slides. Then coming to the application perspective, there are a lot of application related to lattice structure. So lattice structure, which are nothing but a repeated array of unit cells, we call it as lattice structure. You can see this pink color diagram. So this is a lattice structure. This is the simplest cubic lattice structure. So these lattice structures are easy to make. If you are making, you don't need any kind of specialized software to make the lattice structure. Okay, if you are making a normal sample using the slicing software itself, you remove the outer shell wall, you reduce the infill density to 10 to 15%. Now you can automatically develop your lattice structure. In yesterday, I have told you lot of infill patterns are there. Okay, the same kind of infill patterns if you use for developing this kind of lattice structure without shells, if you adding these kind of infill patterns, the lattice structure will be developed. Okay, the simplest term for lattice structure is a repeated array of unit cell. If you are making one unit cell and you are repeating in a separate pattern, you call it as lattice structure. Okay, so the application for lattice structure, why you are going for lattice structure? Lot of people telling if you are using lattice structure now you can increase the strength. It is not like that. If you are adding lattice structure now, the strength will not be improved. The modulus was improved, which is nothing but the elasticity was improved if you are adding lattice structure. So where you are going to use this kind of lattice structure now, the area where for example, I will show you the simplest example using implants. Okay, if you are going to make a bone implant, which is a implant which is nothing but if you are making any kind of scaffolds. Okay, the porous structure, you can see this one, the blue color one. This is a porous structure which is a bone mimicking lattice structure. Okay, bone mimicking lattice structure. So if you are making these kind of lattice structure now, you can put you can use, if you are going to put it in a human body or else inside any of the animals or human body, anything you are going to put. The main problem arises during using this kind of metal. If you are using titanium or else cobalt, any kind of metals you are going to use, and you can use that as a source material for developing these kind of implants. Now, the problem arises during this implant if the time after several years or several months, there is an chances of stress shielding effect. If you are walking fastly now, there is a difference in the mechanical property of the metal implants with respect to the bone. So the bone which has certain Young's modulus, okay, the metal which has certain Young's modulus, it can be matched when you are going to put it into the human body now. So these kind of things can be done by using lattice structure. If you are using this kind of lattice structure now, you can mimic the bone kind of lattice bone kind of structures in the implants. So this can be very good when you are using this kind of application. So what is the problem? If you have the stress shielding effect has been happened, what can occur in the implants? It can be maybe loosen the screws, or it may be failure occur. Like that, it can, a lot of problems will occur if the stress shielding has occurred in the samples. Okay. Then coming to pyramid-based structure. So this kind of pyramid-based structure can be used to insoles or else any kind of grip kind of patterns like that. If you are working on tribological-based application, now you can work on this kind of pyramid structure, this kind of stripped structures, this kind of twisted core structure. These are very good, useful for you are using for uh, tribological application. Okay, then why you are going to use for honeycomb structure? So honeycomb structure has a very good advantages for thermal kind of application. This kind of honeycomb structure which are having better thermal insulation capability. So if you are using this kind of structure now, it will be very good. But this honeycomb structure is a planar based honeycomb structure. So you, in order to improve your performance, you can go with the TPMS structure. The TPMS structure, which are nothing as here they have mentioned as TMPS. It is not TMPS. It is TPMS, triply periodic minimal surfaces, which is called as TPMS structure. This kind of structure, which is a three-dimensional lattice structure, it can improve the thermal all properties in a very enhanced way. Okay, using logarithmic formula, we can develop this kind of TPMS structure. So in order to develop these kind of TPMS structure, specialized software required. So normal slicing software or else normal fusion you can use TPMS structure. But in order to you want to develop your own structure now, some specific softwares are required. From the nature derived or lattice structure also, it is possible to develop. This and all you need some kind of peculiar software knowledge you need. Okay. So now I will go into the presentation. Today I am going to cover two main important topics. One is medical 3D printing. Another one is composite 3D printing. In medical, the term medical 3D printing, which is nothing but you are going to develop, you are going to use a 3D printing in a healthcare application. We call it as medical 3D printing, which is mostly used for a clinical and healthcare application. We call it as medical 3D printing. Okay, so mostly they are using to develop a surgical tools, prosthetics, as well as patient-specific implants, as well as patient-specific models for various kind of organs development, and also like that we are going to use these kind of medical 3D printing application. Okay, so first one which will be developing of medical devices, then we are going to use it for testing and planning, and then R&D, then medical education. So where the medical education will they are using means, currently they are mostly most of the medical colleges they are using cadaver for the students. Cadaver is the most important one for doctors. Okay, so when you are going to study nowadays, it is a lot of restrictions are coming towards the usage of cadavers. So buying the cadaver it is very difficult for the medical colleges, and also in medical colleges the strength also increased. So they need lot of new advanced technologies for the education purposes. So they are using one of the very unique technology called digital anatomical printing, which is related to polyjet. They are using these kind of technology for the development of cadavers. Okay, coming to the market size of medical 3D printing, it was around 1 billion USD. They have expected for 1 billion USD in 2026. Maybe it may be reached now itself, because it is going to finish like 2025. So maybe it may be reached. I don't know about the exact scenario now. This is the old data. Okay, so so where we are going to use these kind of medical 3D printed parts. Okay, first one for organ developments. Okay, if you are using which kind of printing technology you can adopt for this kind of development, you can use bioprinting. In bioprinting itself, bioprinting is the simplest technique, which are they are using extrusion based 3D printing. So the extrusion can be classified into piston based. Yesterday itself I have discussed those things: piston based, or else pneumatic based, or a screw based. Like that, there are lot of types of that. So in bioprinting, they will fill the bio inks. Bio ink, which is nothing but the commercialized polymer, which is a biopolymer, along with that human cells, which is nothing. They will take the human cells. I will discuss those things from the coming slides, and they will mix it, and they will grow in a certain environment, and they consider this as a bio ink. So using this kind of bio inks, they are developing the organs. So this is called, they will use bioprinting for medical application. Then they are developing various kind of pharmaceutical applications, like they are developing drugs, which is nothing but this also I will explain in the upcoming slides. I have slides with a good figure. And, okay, so then personalized drug, like then also complex implants development, patient specific implants. Okay, if you want to develop a patient specific implant, now you should be aware with the design skills as well as manufacturing skill. Everything is required. So what are the skills you have required for developing implants? Now I will show you what are the softwares required, what are the things you are upgraded. You can teach your students also. These things are much more required nowadays, because nowadays most of the area automation is ruling. So if you are trained your students related to this kind of application, it will be very good. Because I am a mechanical engineering guy, but I am now currently working in a last 3 years I am working in a medical college. Now I am working in the bio systems and machines center. So a mechanical engineer can easily fit into this kind of stuff. Why? Because we have interdisciplinary knowledge, and also we are using various kind of softwares as well as a manufacturing skill. For the product development, you need a both design as well as manufacturing skill. So this can be taught by yourself to students. This is the must one. Okay, then coming to anatomical models for surgical pre-surgical studies. These are very much this one, which is costlier one when compared to other 3D printing process. Bioprinting and anatomical 3D printings are costly one, because in India we don't have this kind of facility in all the places. It has a limited facilities are only available. So we need to much more concentrate on theoretical part. If you have any kind of things, you can approach us. We have some facilities for these for composite printing, for anatomical 3D printing, and bioprinting. So we have facilities, and also we are using various kind of we have access for various kind of softwares for implant development also. I will discuss those things in the end of the slides. Okay. So what are the benefits of medical 3D printing? So you can entirely replace the first one, which is the cadaver. Okay, you can entirely replace this kind. So there are some for the student training purpose, they are using these kind of cadavers, but you can eliminate these kind of things with the 3D printed parts. Okay, then the second photo, which is as training models. Okay, you can see this with the white one, which is the leg models, which is the bone kind of things. You can print these kind of model using extrusion based triple F printer itself. But the problem by using these kind of printers is it will not exactly match the consistency, which has bone, which has a mineral density. Normally samples which are having the hardness value. But in the case of bone, it has a different kind of parameters are there. For bone, it has a bone mineral density is there, hardnesses are there. There are a lot of parameters can consider for the bones. So you should aware about these things before selecting the printing process. Okay, if you are going to use this kind of model, if you are going to develop this kind of implants, okay, if you are going to use this as a pre-surgical model, pre-surgical, you are going to use this as a check the fit for the implants. Now you can use FDM process. But in case of you are going to do pre-surgical studies, now you should use PolyJet technology, because PolyJet has used a lot of materials and they have optimized the printing studies, and they have comes with the very good parameters for the development of bone as well as skin, everything. The skin, which is a multiple layers. Okay, so you can touch your skin and you can feel it. The first layer, which is very hard, but if you go inside, now the second layer, third layer will be very soft. Okay, so like that, the each layer, the shore hardness value will be different. So this can be given by using the PolyJet technology. The second, then the third one, which is the organ development. Okay, and also if you want to make multicolor prints, so I have the videos, but I am not able to add it in the presentation, but I will show you after the presentation. I will show some of the videos related to PolyJet printing, which is mostly used for an business kind of application, like they are using color models for making toys, your human statues, like that they are using with a colored model. It is possible to do using PolyJet printing. Then implant development is the most effective platform for the medical 3D printing, because in olden days the customized implant, we call it as patient specific implants, we call it as PSI, patient specific implants. So these kind of patient specific implants are very good and very much beneficial for using 3D printing. Okay, because during nowadays we are using lot of softwares. Typically we are using N topology. Okay, N topology. We are using this software for topological optimization. Okay, and also the material consumption. We are reducing the material consumption. Okay, it may automatically reduce where are the which places you want to eliminate the material. You can use this kind of software, and it automatically remove the unwanted portion material, and it will give you the exact implant with the minimum metal usage. Okay, so these are the advantages of using 3D printing. Okay, so what is the outcome of 3D printing? So when you are using 3D printing now, you can develop your customized implant with the best fitted implants. Okay, so it may automatically reduce the surgery time. If your implant is not exactly fitted with the, if you have a cranial defect. Okay, so you are going to develop a implants for craniosurgery. Okay, so if you put these kind of cranial defect now, the exact size now you can easily put, and you can exactly screw those places. But the implant size is somewhat small now. You need to enlarge the portion and you need to bend it. Like that, it will irritate the surgeons to fit those things. Okay, so it may reduce the customized things. It may reduce the surgery time. Okay, then and also blood loss. If you take more time during surgery now, there is a chances of high blood loss. But it is not possible. It is not by 3D printing process. Then post-operative risk, which is nothing but if the implant size is not perfectly fit, there is a chances of failure. So this can be avoided when you use these kind of customized implant or customized models. Okay. So what is the need of pre-surgical models? Now I am going to discuss more about how to make the pre-surgical models and related things I am going to discuss more. So the first one, which is I am going to discuss what is the need of pre-surgical model. The first one I am showing you is, in general, if you are fabricating a tire. So what a mechanical engineer or manufacturing engineer will do. So they are not going to fabricate. First they will design the tire. For example, I am discussing more about road tire industry. Okay, so if you are designing a tire, so you are not going to directly fabricate the tire, because polymer based product I am telling you with you tire. Okay, so before that you are going to run with the for example, if you are going to do some kind of wear analysis, okay, or a simulation kind of stuff. Okay, so if you do simulation, why you are going to do this kind of simulation? Because you don't want to invest money before knowing about the quality as well as the strength, everything. You need to analyze before going to use it in the real-time application, because the investment was more. But in case of healthcare industry, you are not going to invest, you are going to do in the patients. Okay, so the value is depend on the how you are going to do the surgery. So you need to train. Okay, nowadays most of the PGs are nowadays they are accessing the patients. Okay, so you can't give the patients for the surgery just like that. Okay, so nowadays the patients are doing these kind of pre-surgical studies using these kind of models. So they are using some kind of sinus surgery using this kind of patient specific model. These kind of models are commercially available in the internet itself. If you have the printer, you can develop these, you can print these kind of models. Okay, but how it is exactly fitting with the pre-surgery. Okay, every patient has different kind of complications. Okay, so this one is a generic one. Okay, these kind of things are done using during the like a laboratory activities like that they will give. Okay, but in case of real-time activity, how they are going to do, I will show you some slides how to make these kind of pre-surgical models. Okay, so what is the need of pre-surgical studies? Okay, so in olden days they are using for if you are going to do a surgery, if you have a stone in the kidney, okay, or else you have any kind of bone fracture. Okay, so how they are going, if you have a fracture in your hand, so you want to going to use implants, so you are going to develop an implant. So okay, so you want to make develop an implant. So you need, in olden days they are using X-rays. Okay, first they will take an X-ray, then they will see where the crack is there, and they are measuring the crack length. Everything they will measure it, and they will consider this amount, this much length of bone plate is required. Like that, they will tell to the designer, they will design the bone plate with respect to this length, but they will not exactly mimic. So if you have the bone fracture from this portion to this portion, they will measure it, and they will make a beyond this portion they will make some length of implant. But the fitting again, it will come with fitting problems, or else after opening only they will know. If you have if they have some kind of minor cracks, the crack will penetrate if it is not properly addressed. Okay, so this can be addressed by using these kind of pre-surgical studies, because if you have this kind of CT for bones, we use CT. For skins, for example, organ based things, if you have a tumor in the kidney, you want to do the surgery for kidney tumor, you can take MRI data and you can do the pre-surgery. So okay, I will discuss those things on the coming slides. I will show you one patient specific data. I will we have what we have done, what we have achieved, like that I will tell you. Okay, so what makes the value to the doctor means, if you do it in a correct way. Okay, how much quality you are giving to the patient, and how much cost you have reducing for the patient. So if you giving less cost with a good quality, the people will consider, hey, he's a very good doctor, he will do it in a very, very good manner, like that they will give you. Okay, the quality of the doctor is based on the quality, the quality they have. And also we need to consider cost also. But when you are using this kind of patient specific model, the cost will be added. But in the coming days, the polyjet printing cost will be reduced, because statuses owned this kind of technology also owned by statuses. Last year the patent rate was closed. Now itself China has already enrolled into the market, and they have developed lot of polyjet printers. Nowadays itself they have giving a lot of low cost printer itself. Okay, so polyjet also nowadays the cost for printing polyjet printing also now it is reduced compared to in olden days. So you can use these kind of models. Okay, so you can I don't want to discuss it. So now I will discuss more about polyjet 3D printing. What are the materials, what are the things they are using? Okay, so there are a lot of materials. If you are using the human developing human skull, so what are the materials you need? If you want to develop a spine, now you need both hard as well as soft tissue. In polyjet printing, there are a lot of materials are there. Okay, they are using photopolymer as a source. The photopolymer, which is a polymer, just looks like plastic, as well as rubber. Rubber is a flexible one. Plastic is a rigid one. Okay, so wherever you want rigid one, you can use polymers, which are there are a lot of materials are there. I will discuss in the upcoming slides which what are the materials are there. Okay, so this is the polyjet printing process. This is the tab on, you can see like this only. the polymer was fed into the bed and it can be printed. The first layer, which is a supports. Okay, first the support was printed, the next layer, the material which is coming. Okay, there is a Verro Agilus based materials was printing. Okay, so this one is the part, the outer part, which is a support. So these supports which are easily washable, water washable supports. Okay, so you can easily just put it into the water, or else a washing chamber. Na, the water, this kind of supports can be easily removed. Okay, so what are the main things in the polyjet printer? Okay, so you can use, there are 7 nozzles are there. Okay, sorry, this is for 7 materials for JAP J750. In DAP J850, you can use 7 different materials and 1 support. Okay, the material would be bone, gel, tissue, and radio matrix. So these are the different kind of matrix, which is nothing but bone, which is a bone matrix, exactly mimic the bone property. We have already tested with the conventional bone, with the bone matrix material, and we have checked with a lot of parameters like drilling, kind of things, because mostly in patient specific models, we are going to make implants as well as bone plates. So if you want to study the bone drilling studies, now it will be for mechanical engineering, this would be the best way of comparing these kind of things. Then gel matrix, which is nothing but the material which you are going to develop lungs or any kind of tubular structures or esophagus, like that. A lot of things are there. So those portion you can't use support material, because removing the supports are difficult. If it is water washable also, because the complex profile is difficult. But you can use gel matrix as a support. Now you can exactly just squeeze it and we will remove those kind of material. Then tissue matrix, which is nothing but a skin kind of things. Then coming to radio matrix, the radio matrix, which is nothing but the material which are mostly used to for making bones. Why you need radio matrix? Okay, so everyone knows what is the principle behind the X-rays. Why the X-ray showing bones but it is not showing our dress or skin? Because it has some kind of radiation emitting, and the radiation was not emitted during this kind of things. So there is a material, they have material called radio matrix, they have developed with a radiation property. If you use this kind of material, now you can exactly, after drilling, if you want to exact mimicking of bone matrix with the if you can drill it and you can put it into the X-ray machine, again you can check what happened with the crack length also. You can discuss how much the crack it was penetrated, like that also you can do. So these are the advantages of various materials in digital anatomy printing related to DAP J850. This is one of the finest printer I have worked till now. You can use various kind of Verro, Agilus. These are the material which are used to enhance the properties. Okay, Verro, which is a rigid material, Agilus, which is a soft material, which is mostly used for the anatomical model. Though you don't want to make these kind, you want to only with a multicolor printer with the specific models. Okay, I will show you the lot of models. We have developed a lot of models. I will show those models. Those models we have used only Verro and Agilus. These are the color materials, but for showcasing models, we don't need these kind of models. These are mostly used for pre-surgical studies, not for a showcasing models, because these materials are very costly. Okay, so first one, they have developed a spine one. So they have used Agilus clear as well as tissue matrix with the bone matrix. Combining Agilus with the tissue matrix, they will develop these kind of soft one. For bone matrix, they will use the exact same bone matrix itself, because this is a patient's kind of things. Then if you are going to make a bone kind of stuff, okay, so the bone, which is a porous structure, already you have, it is a cortical region, this is a trabecular region. So the cortical region which are having different graded porosity. Okay, so we have done on studies related to these kind of bone mimicking structures using software. I will show those things in the coming slides. Okay, so these also, if you want to grade these kind of things, now it is easy, because the slicing software itself, you can use for graded porosity. That's not all possible. Then if you are going to develop a heart, okay, you just need only tissue matrix with argillus. So you can and also you need to fill inside with a gel matrix, because you want to remove those things using gel kind of things. Okay. So this is the properties of the tissue matrix, but I don't want to go in depth of these things. So how to make design models. Okay, what is the role of engineer here? Okay, these are the things I am going to discuss now. So the first one, digital data. You need a digital data for developing your model. Okay, the first one, what is digital data? Okay, if you have a bone fracture, I have already told that if you have a bone fracture now, you need a CT data. If you have any kind of tumor things now, you need a MRI data. Though first you need a data. The data will be in digital or CT or MRI. But you are going to develop this hand. Okay, if you want to make a model for the hand now, you need both CT as well as MRI data. Combining both the data, you need to develop the hand. Okay, so first we need to take a CT, then we need to post process the data. Initially, if you are taking CT data and MRI data, which is called DICOM file. The file we call it as DICOM file. After getting the DICOM file, we need to post process. After we need to import these kind of software into the segmentation software. First, we need to segment bone separately, organs separately, like that. If you want to, I will show you some of the slides related to. I will show you those slides. So you need to separate everything. And after segmentation, you need to pre-process. You need to pre-process in a specified software. We call it a geomagic freeform. In the geomagic freeform, you can develop what are the things you need. If you want to eliminate the unwanted portions, you want to remove some of the errors, everything, threshold level adjustment, what are the bone level, because bone which has some certain threshold value, skin which has a threshold value. We need to adjust everything, and we need to segment bone separately and skin separately. Okay, after segmenting, we need to post process the data using sculpting, like a trimming and smoothing. Everything we need to done before going to convert into this as a STL file. Okay, so here you need a technological guy knowledge. Okay, how to do those things. But only technological guy cannot do those things, because if I am a mechanical engineer, I am a technological guy, but I don't know which is an organ. Okay, exactly. Okay, what are the veins are there? I don't know. That time we need a support from a medical practitioner, like a doctor or a surgeon or radiologist. We need these kind of support from the medical domain specialist. Okay, after getting those things, we need to segment those things. After that, we need to finish and develop our STL. Then we need to print the model. Okay, that time also the technologist, which is nothing but an engineering guy, needed. Okay, we need to convert this STL into G codes. We need to do a lot of things. Okay, yeah. Then during printing, there is a chances of failure will occur. So everything we will do. Okay. After that, we need to put these models for a pre-surgical studies. Okay, this is the simplest way of using how to convert the medical model using 3D printing technology. So bioprinting, I will show discuss these things in the upcoming slides. So what are the major technologies we are going to use for the medical 3D printed component development? Which first one, which is the triple F based printing technology, which is nothing but extrusion based. Instead of triple F, we can call it as extrusion based. Okay, because nowadays instead of triple F, they are using FGF also, fused granular fabrication also, for making pre-surgical models. Okay, for like a cast models. Okay, ceramic based cast also nowadays they are making. Okay, then SLA for making dental implants, dentures, crowns, as well as aligners. Everything they are doing by using SLA printer itself. There is a company called Toothsee. Do you know anyone? The Toothsee, which is one of the biggest company, but they are failed because within 5 minutes they will reach your place, like that. They will give you the implant within half an hour. They will give you that aligners, like that. But the problem during these kind of aligners, which are not effectively utilized for aligning those dental dental things. So that was failed. But if you are doing these kind of things using 3D printing technology, it will be very good, because they are using technology which are not a commercially rigid one. Okay. Then coming to DMLS, mostly DMLS or as SLS are that also they are using for making metal implants. But the commercialized FDA approved printer would be DMLS. UIS is the one of the best printers for making implants. So mostly we are going to discuss more about spinal and craniofacial surgeries, because these surgeries are based on the accidents. These kind of implants are mostly they are using in various kind of companies. If you are strong in developing these kind of implants, there is a one company called Striker. Okay, he's they are the pioneer in the area of implant development. But nowadays there are a lot of startups they have developed. They are making their own implants, and they are supporting with the locally available medical colleges. But the thing is, you need to get the approval from the FDA. This is a big task. But if you have good knowledge on these things and you have a good financial support, now you can go with this kind of implants things. Okay, this kind of machines, and you can make your own startup. Okay. Then DAP printer, which is a digital anatomical printer for pre-surgical models, and then bioprinting for organ transplant, organ development. Okay, so for if you want to make your own kidney itself, you can make our own kidney. You can take the cells of the patient. Okay, you can develop the kidney, because I will show you some of the slides in US. Some of the research people, they have developed their own organs. Okay, I will show you their kidney, ear model, bone model, everything they have developed by own. Okay. So how to make a pre-surgical model? So this is the simplest step. I am going to tell you how to make a spine model. So first one, you need a MRI data. For spines, you need both MRI as well as CT data, because in the spine, it is a combination of both the soft tissue as well as hard tissue. So you need to take both CT and MRI. You first, after taking the DICOM data, you need to import the DICOM data to D2P software, which is called DICOM to print software. So once you feed the DICOM data, which is the digital data, you are going to convert it into 3-dimensional data. After converting DICOM data into the STL format, you need to put these things in the other plugin. You can use those plugins to segment those organs. Okay, after segmenting those things, you need to put the segmented one for pre-processing purpose. After segmentation, you need to pre-process using GeoMagic software. After pre-processing, you need to convert the OBJ file into STL format. After converting the STL file, you need to put it into the 3D printer. Okay, after those things, you need to get your own model. But the thing is removing the supports, because this is water washable supports, but the complex areas, it is difficult to remove those supports. So you need to remove the supports by using some kind of chemical agents like sodium silicate, sodium hydroxide, some kind of some materials. You need to add certain portions, and you need to put it into the bath, and you need to remove those things. Okay, so coming to the next one, which is the real-time model, which we have done using which is the patient specific data. Okay, so in this patient specific data, we have taken patient MRI data. He has the patient came for a headache, and we have checked for any tumors are available inside the head. So during those days, they have checked with the circle of Willis. So circle of Willis, which is nothing but a main zone in the brain. Okay, this is the tree of the brain. So we have extracted or segmented the circle of Willis from the human part, and we have 3D printer particularly for patient. This one, why we have done that, we are going to showcase those things to students for training purposes. Okay, so initially we have taken patient specific data, which is MRI data. Then we have imported to D2P software. After that, we are segmented. After segmenting, we will be post-processed, and finally we have 3D printer using DAP printer. After that, the support was removed, and it was immersed in the water bath or outer bath. Then we will, after segmenting, this is the circle of release of the patient data. So this is the first case we have done with the pre-surgical, we have done by our CT and MRI data. So this is some of the examples for how they are doing pre-surgical studies. This is one of the simplest example. You can see the renal artery veins, they are going to cut down because these veins are very, very sensitive portion. Okay, so if you are giving little bit pressure itself, it will be cut down. Okay, so you need to do these kind of models. And also if you are developing automated robotic based surgery, also you can use these kind of models, and you can train the robot using these kind of models. Okay. So these are some of the examples of the polyjet printer. The first one which you see is a silicone baby with the umbilical cord and placenta. So these kind of things we have printed mostly to showcase for students how the baby looks, how the umbilical cord looks, and the placenta. Now in olden days you can see in each hospital they will put each water bowl like they are put the babies with the different months they are. Okay, nowadays they are using these kind of models as a design data. If you want to showcase to the students, they will give this model and they will print out. So these are the some of the models. The next one, which is a very good model, which is related to fixation of screws. Okay, so this case, which is a tumor which is available in the kidney pelvis portion. Okay, so first we have this is the tumor. Okay, so they want to print it in both clear material and as well as bone matrix material. Why they are printing in both the condition means for visualizing what are the veins, what are the places you are going to drill. Okay, so they are used clear material to for the bone fixation. They have used the clear material and they want to check how much region they are having with this kind of tumor. Then they are using bone matrix because they are going to fix with the screws. Okay, they want to drill the portion. Okay, so they have used these two conditions for the orthopedic case and they have successfully done the surgery. Okay, then tumor in the child face. Okay, that also they have printed with the different colors and the length and how much energy they have cut down by different conditions. Okay, these are the different kind of examples. So this is the simplest thing. This is my CD data. Okay, so I have segmented my own organs and I have 3D printed using polyjet technology. This is my CT data. I have used CT with fusion of some kind of solution liquids. I don't know exactly the name. For to enhance the veins, I have used this technology, and we have taken this CD image, and we have 3D printed. But if you increase the size now, it will be come in a good way. Okay, so these are the portion which are the some kind of errors. But if you post process it in well now, it will be printed in a very good manner. Okay. So these are the multi-textured head model. These are also 3D printed in a polyjet technology. You can see the accuracy of the prints and the textures. Okay, if you see the texture, which we have used various kind of software for developing these kind of models. We have used Blender and we have used Geomagic. We have used D2B. We have used a lot of software for this model processing. Yeah, and we have 3D printed in a very good way. So these are the some of the internal portion of the 3D printed models. This is a section view head model. Then we have 3D printed a hot one. We have 3D printed this is one of the. So I will discuss this one. You can see this head hand model. Okay, how much the vein sizes. These are very small vein. Printing these kind of veins using other technology, it is very difficult. And also if you print with this multicolor printing, some using other technology, it is very difficult. Okay, so coming to the next one, which is 1 minute, just a second. Yeah. So this portion you can see, this is a kidney tumor of the patient data. Okay, this is the MRI data of a patient. So the doctor came to us. They have the surgeon, not a doctor. The surgeon came to us, and they have given this data, and they want to check the tumor size because they are going to do the surgery. So they want to check the size of the tumor, and they want to print it in a polyjet printer. Okay. So initially we have think that because this is a kidney kind of study, we have think okay sir, we will take care of those things, and we have immediately started those, the project, and we have initiated with the initially we have inserted the MRI data into the segmentation software, and we have erased all the unwanted portion, and we have started using threshold arrangement. Okay, we are reducing the threshold value in a small quantity. We are reducing the threshold value. Initially, we think that one side of the kidney is having the tumor, but finally we found out both the kidney which has a tumor. We are shocked with the things, and finally we show these things to the patient as well as surgeon. Then surgeon plan to stop the surgery, and they are going with that prescription based thing, because already both the kidneys have a tumor. Okay, so this can be found out if you are facing these things in two-dimensional view. Now it is not possible. We have done using this kind of software. We have analyzed. Then nowadays in our college they are using all the cases. They are using this software for checking all the things. Okay. So this is somewhat about medical 3D printing. Now I am going to move towards composite 3D printing. Okay. So before going to composite 3D print, I have already told you that there are mostly I am going to concentrate more towards extrusion based composite 3D printing. So here I am going to discuss more about FDM, then direct ink writing, then pellet based extrusion technique. Okay. The first one I want to discuss more about materials. Here I am going to discuss more about PLA, then PCL, then PMMA. Okay, these are the main materials, and also PEEK. The PEEK, which are very costly when compared to these three materials. If you are going with medical grade materials, all the materials are also costly. Okay, PLA, PEEK, PMMA, PCL. The material which are commercially available PLA material, which are not able to use in the biomedical application. In the market they are giving you per kg 650. Okay, this and all not able to put it into the human body. Okay, you need to buy a PLA from the FDA approved seller, because you are going to put it into the human body. Okay, it should not have don't have those kind of things. Okay, then hydrogels. There are a lot of hydrogels are there. Here I am going to concentrate more about gelatin, sodium alginate, and gelatin. I am concentrate. Collagen and all we have not yet worked till now, and I will discuss the ceramics, hydrogel, everything in the upcoming slides. Okay, so this is one of the slides we have developed for the one of our review paper. That paper got accepted 5 minutes before, so I'm happy for that also. So these are the materials. They are mostly used for the composite 3D printing. So you can see these are the various kind of synthetic polymers. Okay, what kind of application you are going to use? If you are going to use material for orthotics or any kind of external kind of prosthetics or else orthotics for the external supply, now you can use TPU, TPE, EVA, TPU, TPE. These three materials which are very PVA, not PVA. These three materials are very flexible material. Okay, this PVA, which is a binder kind of material or a support material, you can't use this kind of PVA for a somewhat some better application. You can't use because the strength was very less. Okay, coming to PCL, PCL is working similar to a PLA. This PCL and PLA are biodegradable. PCL working on low temperature polymer, and it is a thermoplastic which is low temperature. You can melt it at a low temperature less than PLA itself. Then PEEK, which is a high temperature thermoplastic, which are mostly used for an high strength application and engineering application. If you use engineering grade for various kind of tribological properties, if you use medical grade now, you can use it for a better implants development. Particularly for scaffold kind of things, you can use PEEK based materials. Okay, it has a good bio compatibility as well as biologically it is very fit. Okay, strength also comparable with that PEEK, bone. So PEEK is a very good material for the scaffold or kind of other implant development. Okay, The coming to biopolymers, these are biopolymers. Okay, mostly these polymers which are they are using direct ink writing methods are a bio ink formulation. For bio ink formulation, the hyaluronic acid, which is one of the main material used for the cosmetic industry. Okay, for cosmetic industry, for the skin kind of application, they are using hyaluronic acid. In most of the advertisement, you can see this kind of fonts and other kind of they will tell us they are using hyaluronic acid as a skin glowing agent like that. So hyaluronic acid, which is more very much useful for cosmetic industry, collagen, alginate, chitosan, gelatin, gelatin gum, agarose, which are these are the low temperature polymer. They are mostly used for a gel kind of materials. If you are going to you develop a wound healing for wound healing application, you are going to develop an kind of plasters kind of stuff. Now you can use this kind of material. And also, if you are going to develop an organs, you can use these kind of natural polymer as a source, and you can add you can seed the cells into that polymer, and you can develop your organ. Okay, coming to metals, they mostly prefer for titanium, cobalt, chromium, cobalt alloy. Okay, nickel, titanium also they will use, but in other alloys which are very very costly and also difficult to print, that is the problem. But nowadays they are not mostly used for stainless steel. Mostly they are going for a titanium based as well as cobalt based alloys. Okay, the cobalt based alloys which are very dense compared to titanium alloys, but mostly people prefer for titanium alloys. This is somewhat better, but it is costly. Okay, so coming to ceramic, most of the ceramic they are using was beta tricalcium phosphate along with that hydroxyapatite. Hydroxyapatite is a combination of BTCP as well as calcium. Okay, calcium based minerals. It's a bone minerals. Okay, tricalcium phosphate with beta tricalcium phosphate. These are the most materials they are used in the bone minerals. Okay, hydroxyapatite, everything which are in the bone. So if you are making bone kind of thing now, you can select any one of the material. Okay, so I will discuss one case study related to this ceramic clay printing, one metal printing, one natural polymer based printing, one synthetic polymer based material. Okay, apart from that, I will discuss one case study which is related to peak material. Okay, I don't want to discuss more about the printing parameter processes, because yesterday itself I have discussed a lot about the printing process parameter. So coming to composite printing, there are a lot of composite printings are there. Among the FDM process, first process which is particulate based FDM approach, second one which is pellet based composite printing, the third one which is a particulate based SLA printing, the final one which is a multi-stacked onic composite, which is a continuous fiber based composite, because this kind of printer, the resin will come from one nozzle, and you can feed one other one nozzle into it, and you will feed the wire, which is the continuous fiber as a wire, and you can deposit continuously along with along with you can see the commercial wires. Okay, inside it will be a copper, another one outer side which is a polymer. Like that, these also using this kind of technology for continuous carbon based composite. Here I am going to discuss more about particulate based composite preparation. Okay, so there are different types of composite making. So the first one, which is filament based composite. How they are going to use filament based composite printing? Huh? Initially, you need to select thermoplastics. Thermoplastics. Why I am selecting thermoplastic? This is injection based. Injection based in extrusion, the material need to be melted, and during melting, the fiber or a particulate or else any kind of fillers you are going to add, it need to be mixed together. So there will be a 3 zones. First zone we call as feed zone, the second zone which is called a melting zone, the third zone which is called as a melt pumping zone. Okay, the feed zone which needs somewhat higher temperature. Okay, why? Because initially the material need to be melted, it need to be the viscosity need to be reduced, because in the melt zone the material need to be mixed together. Okay, so in the feed zone the material temperature was higher when compared to melting zone. In finally in the melt pumping zone, the material need to be pumped out from the nozzle. Okay, this is the simplest thing. Okay, this one is called single screw extruder. The second one, which is called twin screw extruder. So you want to make a uniform extrusion of the material. Now you can use twin screw extruder. If you want to add more kind of composite, now you can add 3 kind of composite. You can mix it with the 3 different nozzles. You can attach here at a different level. You can adjust it, and they will feed every 2 minutes, every 2 minutes, every 3 seconds once the filler will be filled with this pellets. Okay, that technology also nowadays came. But commercial olden days they will mix together pellets as well as fiber. They will mix together and they will put it into the hopper. Initially, they will do first with a single screw extruder. Based upon the melt and the melt of the filaments, they will chop down into small pieces. Then they will put it into the thin screw extruder and they will extrude into the wire form. Okay, this is the simplest thing. So compared to single screw extrusion, in filament based technology, in pellet based extrusion, there is a cylinder where the pellet was filled together. This is the, for if you see this D image. Okay, so if you fill the pellet into the chamber, this is only the nozzle. So you will, based upon the nozzle size, if you are going for pellet size printer, similar to the filament extrusion, after making into filament, you can chop down into your pellets and you can directly put it into the barrel and you can directly print it. But the problem during this pellet based printing is you are using pneumatic based technology now. The nozzle size should be higher when compared to the triple F based printing. Similarly, the strength also decreases because if you increase the nozzle size now, the layer height also increase. So strength was reduced if you are using pellet based 3D printing. And also the profile surface roughness also increased. For complex profiles, it is difficult to print using pellet based 3D printing. If you are using normal virgin polymers, now you don't worry about the extrusion head size, because for melting the pellet you need somewhat higher nozzle size. That is the main drawback in pellet based extrusion. So coming to direct ink writing, you can mix your own material and you can if you are making your cleaner, I will show these things in the upcoming slides. This is the food, in the food packaging industry. They are using multiple nozzles and they will printing with a different kind of materials. Green color is one material. Orange in the C image you can see orange is a different material. They are using multiple heads to print those things. So I will discuss these things in the upcoming slides in an elaborate way. So this is the simplest thing for making publications. Okay. Because here most of them are related to faculties, I think so. It's a faculty development program. So every institute, they want the faculties to publish some papers. Okay, so in NARF ranking, QS ranking, everywhere they are targeting publications only. So how you can make your publications using composite 3D printing? I will discuss these things in this slide. Okay, so already I have told that for polymer composite you need reinforcement and matrix. Okay, these are the main materials. Okay, so you can select your reinforcement. The reinforcement may be organic or inorganic. What kind of application you are going to use, you can select your reinforcement. Okay, then you can select your polymer. The polymer may be any material. So most of the people select PLA because it is a low temperature material, commercially available material, and it is easy to print in all kind of 3D printers. Because if you go with ABS, PEG or P composite, it is difficult to print. Okay, so people will go with the PLA. So if you are targeting towards publication perspective, now you will go with the PLA. Why I am telling PLA means it is easy to process. Okay, that's why I am telling select with the one PLA. Then you will go with the reinforcement. The reinforcement should be effective material. What type of reinforcement you are going to do? If you are going, for example, I will tell you, I have initiated with the crab shell. Okay, I have directly put crab shell as a one in one of the publication. I have used directly crab shell as a reinforcement. But in the next publication, I have extracted chitin, cytosine, hydroxyapatite from the crab shell. I have synthesized hydroxyapatite and I have used as a reinforcement in one publication. And I have extracted chitin, cytosine and chitin from the same crab shell. And I have mixed with the biopolymer like alginate kind of stuff. And I have used these polymer in some other application. So what are the reinforcement you are going to use? That makes a novelty of your study. Okay, so like that you can select your exact reinforcement. Okay, after selecting the reinforcement and polymer, okay, you will melt together these materials and you will mix together and you can put it in the extruder and you can extrude the filament. Okay, once you have extruded your filaments, okay, you can characterize these parameters like melt flow index. Melt flow index now how much amount of load required to melt the material from the extrusion head. So these need to be measured using some kind of specific instrument called melt flow index meter. Okay, you need first you measure the melt flow index, then the filament strength using normal UTM machine. You can see this one. Okay, so you can then filament diameter, just a vernier caliper itself enough to measure the filament diameter, then the surface roughness. Okay, so these are the simplest parameter. You can measure your own filaments parameters, then you can publish this as a short communication. In every journal there is a different kind of publication strategies are there. First thing called review paper, then full length article, short communication, then editorial. So these are different types of publications are there. Okay, you can publish this as a short communication. Then if you want to make the study in depth, you can vary the extrusion parameters like extrusion temperature, the extrusion speed, the cooling medium like air, water, anything in quenching mediums. Okay, then you can change the polymers also. How the reinforcement behaving different type of polymer. If you are going to select PLA, how it is behaving, then you can select with the peak. Peak is a high temperature material. So you can select in between, you can select PEDS. So you can compare these three different polymers, how the reinforcement was behaving. Like this also you can do the study. Okay, then after this extrusion parameter optimization itself, you can do as a full length article. Then printing parametric study. So the impact of added reinforcement in the polymeric granules can be studied by with respect to various printing parameters like infill density. I have discussed lot of infill parameters. Okay, so you can study this as one full length article. Okay, after that the main area is the characterization of the composite. Okay, so you need to characterize the physical property like density, um, mechanical properties such as the physical property. You should measure the void content. Okay, because the porosity is the important parameter in the 3D printed components, because the layer gaps make the sample quality. The sample quality is decided by the porosity. Okay, if the porosity high now, the strength of mechanical property will be diminished completely. Okay, so the mechanical property is decided by the physical property of the extruded material or the printed material. So you need to focus more on physical properties than the mechanical properties. The mechanical properties such as tensile, flexural, impact, all other properties you can study. Then you can go with the thermal studies like DSC, TGA, and flammability. Everything you can characterize. Then biocompatibility, like you can do antibacterial studies. Then you can do with all kind of bio studies you can do it. Okay, then surface characterization like contact angle, surface roughness, everything you can study. Okay, if you do tribological study itself, you can do it as a separate study. In dynamic studies, everything you can do it, and you can completely, you can vary with the different composition, and you can do it with all the studies. Now it itself make it as a big full length article. So this is the simplest layout. I have made this layout 4 years before. Okay, this is a template for us. I will give whenever my students coming to me now, I will give this template. You can use this as a PhD also. You can use this as a template if you want to make your own thesis itself. You can use, you can select one specific reinforcement, and you will do with all the things. Now you can do it this as a PhD also. We are supporting two of the students the same kind of things, and they are going to finish it in the upcoming months. So this is the simplest way to finish your research things. Okay, compared to other metal kind of stuff, it needs lot of efforts. Okay, finally you need publications. Okay, you can easily do those things. Okay, so initially I have started with the simplest printer called flash extruder. So in the flash extruder, we have the energy for melting and purging out the filament was very, very difficult. So initially we have struggled a lot. In this work, we have added silicon particle for the composite making. We have faced a lot of difficulties for the composite making. We have failed beyond 8%. We can't able to extrude a filament. It will come at this like this bulging. You will see this kind of small portion only we will get after 8%. It was failed because the silicon also it need high temperature, but if the temperature we got not able to go beyond those range, and also the motor RPM also we need occur, but all that and all we are not able to do. This is the first difficulty we faced. Then we have designed our own extruder, and we have done with the good kind of extrusion. So these are the things we faced during the extrusion process. The first one, which is the diameter reduction. You can see this is the why the diameter was reduced means if you increase the pull speed now, the diameter was reduced. Okay, so you need exactly 1.75 mm diameter with a less than 5 mm range difference is okay. But if you are reducing the extrusion temperature, okay, there is an over diameter will occur. Then if you increase the particle concentration means here we have used some of the metal oxide. Okay, the increased particle concentration makes the nozzle clogging. Okay, so if you see, this is the shear thinning. I have increased the temperature over 240. Okay, this makes the material more viscous and it is not able to extrude as a thick wire. The shear thinning will occur. This is based on the temperature. Okay. Then coming to the printing defects. What are the defects we faced? Okay, I have added more volume of more concentration of. So I have added a higher concentration of 25% of the filler particles. But the problem we faced is that the bed adhesion was not good. Then we have used some kind of aggressive medium like Fevikwik. Then we have printed that came well. So this one we have added higher concentration of ceramic particles. Okay, added ceramic particles make the filament more brittle. So it was break down inside the extrusion head. Okay, this is the puller unit. Okay, inside that extrusion head. Okay, it was break inside the nozzle. So so in order to avoid these things, you need to add some kind of plasticization. In order to remove these brittleness, you need to add some kind of plasticization. So then warpage. Warpage is also one of the defect. You need to add those things. Okay, so these are the main defects which we faced during the composite printing. So coming to plastic recycling. Okay, I think another 30 minutes is there. Hello. Hello. Organizers. Okay, I will go with another half an hour. Okay. Because I have another 45 slides. That's why I'm asking. So that this work we have used instead of using plastic waste for normally they will use pyrolysis and they are making biocarbons. Okay, so instead of that we can shred our own plastics and we will put it into the extrusion and you can mix with a certain ratio of this waste plastics and you will mix together with the combustion virgin plastics. Okay, so if you use these kind of things now, the sustainability was improving. Okay, so the certain, if you completely use these kind of recycled material for the filament extrusion, it is difficult to extrude the filament. But you can mix certain ratios. For example, the waste recycled materials, you can shred it into your pellets, and you can mix these kind of pellets with the polymers, virgin polymers, and you can extrude these things. Now, the property was not much more affected. The property which how much you are need now, you can get those values. Okay. So coming to case studies, I will go with 6 case studies. Okay, 6 case studies which are mostly related to my publications. The first case study, which is the composite filament extrusion from crab shells. Okay, I have already told you that initially I have selected crab shell because why I have selected crab shell means this is rich in source of calcium minerals. Okay, if you want to make bone kind of bone mimicking or bone application scaffolds now, you need bone minerals for those applications because these kind of bone minerals will enhance the cell growth when you are put it into the human body. Exactly mimicking the bone minerals, now it will easy to cells can be regrow. So initially we have used crab shell, we have synthesized hydroxyapatite from the crab shell. After synthesizing the hydroxyapatite from the crab shell, we have used the hydroxyapatite and we have mixed together with the PLA pellets and we have developed our own filaments. Okay, in this work we have analyzed the properties of the filaments and we have published this in the Materials Letters Journal. It was published in the year of 2023. Okay, so this is one of a good journal. So from the application, it is concluded that 8% of the particle concentration shows, you can see that 8% shows better strength, but the modulus was reduced compared to other concentration. You can see tensile strength was good, but the tensile modulus was reduced because this added ceramic particles reduced the elasticity of the polymer. Okay, if you add ceramic particles now, instead of adding ceramic particles, if you add wood-based particles, now the wood-based natural fillers which are having the better elongation when compared to ceramic-based particles. So the 8% shows better strength. Similarly, the increasing in the particle addition shows decreases in the diameter deviation because there is a reduction in the diameter. Okay, why there is a reduction in the diameter? Because the negative is an indication of diameter reduction because we have maintained the same temperature. Okay, so the temperature is not enough to melt the material properly. So that there is a reduction in the temperature. Similarly, the added ceramic particles, which is a hydroxyapatite, has increased the surface roughness because these added particles which improve the hardness as well as roughness due to the wavy patterns when we are into the normal polymers. Okay, after extruding these filaments, we have think to based on this diameter deviation, we have come with a conclusion and we have extruded with the various parameters. Okay, with respect to various parameters, we have optimized the extrusion parameter. Then we have printed with the optimized condition filaments and we have 3D printed and we compared with the PLA. The results were good compared to the PLA polymer. The main problem using the crab shell, in addition of crab shell, the material which are absorbing more water. So why? Because the roughness was improved. The roughness increases now, the surface area increases. The surface area increases now, the contact angle also increases. So the water absorption also high, and you are using this kind of bone minerals. So what is the advantages of adding this kind of, the water absorption was high now? What is the advantages means? If the water absorption is high now, if you are going to put it into human body now, the blood will easily get enter into the bone material. If you use PLA now, polymer, it is difficult to feel into the it is difficult to spread easily. Okay, so if you use these kind of materials now, it is easy to spread the blood and the cell can be grown fastly. So this is the outcome which we have obtained from this research work. The next work we have used organic based filler. The first one we have used recycled wood, which is nothing but a we have used two different technology. One is we have used a commercialized filler. Another one which is here we have used walnut. Okay, walnut hull as a reinforcement. We have finely grounded the particles and we have used 30 microns, I think so, the particle sizes, and we have extruded the composite filament with the different combinations like untreated and silane treated. We have done two different techniques. One is untreatment and the silane treatment, and we have done these things and we have characterized the property. The strength was good, as well as the mechanical property was very improved well, and also we have studied with water absorption property. Why we have conducting these kind of things now? We are going to use this as a water tub. Okay, so we have developed with the we have compared this with the three different water conditions. One which is a normal water, another one is a salt water, another one is a hot water. So we have done with the three different conditions and we have optimized which composition would be the best for making these kind of baskets. The 5% shows the best results when compared to all other conditions, because increasing in the concentration of filler, it will lead to increasing in the water absorption property. So we have concluded 5 would be the best one compared to the neat polymer. Okay, neat one which are having less water absorption, but the case of you need to balance the strength with respect to the water absorption. From that we have concluded 5 will be the best one for the composites. Okay. So coming to carbon fiber reinforced composite, we have developed various kind of shell-based one. We have optimized with various printing parameter for developing these corrugated tubes. The corrugated tubes are most useful for an energy absorption application. So we have developed with this with carbon fiber based composites, and we have optimized the printing parameter. The result should be the layer height of 0.1 and the printing speed of 30 mm. The printing temperature of 210 degrees Celsius, not a 410, it's a mistake. It's a 210 and infill density of 100% and a build orientation 90 degree. The line width of 0.1 mm would be the best one for making this carbon fiber reinforced polymer composite. Okay. Then coming to pellet based 3D printing. If you want to make the pellet based 3D printing now, you need to mix the material by hand solution casting method, and you can develop your composites, and you need to put it into the barrel, and you need to print it in a things. So due to time restriction, I am going faster because I have a lot of slides to be shown. Okay. What are we are using these 4 materials for medical application. We are using these 4 materials in a very good way. First one, ceramics, which is hydroxyapatite. Next one, which is a polymer, PLA, PCL, PL, DLA, PEEK are the most used biopolymers. Polymers, then metals, titanium and cobalt chromium. These are the most used material for biomedical applications. So coming to the case studies, the first case study. So we have developed a lattice structure for bone applications for scaffold making. We have 3D printed these things with related to PEEK material. So we have selected 3 different lattice structure. One is gyroid based lattice structure. The second one is diamond based lattice structure. Another one is primitive based lattice structure. We have graded with the 2 different technology. First one, which is the relative density based grading. The second one is cell size grading. Finally, we are grading with the combining cell size as well as relative density grading, and we have printed it in PEEK material. So from the results, it is concluded that we are going to use these implants for a bone application. We are going to make these kind of implants for a bone alternatives or bone fracture kind of things. Okay, so we have compared this with the various kind of bone. In bone, there are 2 regions out there. One is trabecular bone, another one is cortical bone. So the current work with the values which are in this zone. So we are compared with the commercialized PEEK materials. This lattice structured one, if you optimize the structure, we have graded the lattice structure with a different parameter. From that, it is concluded that it was somewhat matchable with the trabecular bone. Okay. So if you want to much more, you need to adjust this strength with elastic model. For what is stress shielding? Already I have told that the stress shielding, which is nothing but comparing the strength with the elastic modulus, we call it as stress shielding. So the stress shielding effect will be within this zone. It will be good. Okay. So it is somewhat acceptable with the trabecular bone, but it is very good acceptable with related to cortical bone. So we can adjust these parameter also. If you may vary the printing parameter or design strategies also, we can adjust that the strength as well as modulus. Coming to the metal, so we have developed a PMMA based cranial plates. Initially, we have varied with various design process parameter, and we have 3D printed using this, and we have optimized the design parameters like cell size, cubing angle, wall thickness, and orientation. Among the based on these parameters, design parameter, we have developed the same design parameter, and we have developed the implants. So here you can see we have developed these kind of cranial plates using geometric freeform software. Okay, so and we have used this model for the implant development. Coming to ceramic printing, this is one of the easiest clay-based printing technology. You can see that there are different composition of mixing HNT with the sodium silicate and polyethylene glycol. Polyethylene glycol, which is a material for taking, which is like a in order to reduce the viscosity, they have added PEG. Okay, so you need to maintain the viscosity, which is in extrudable consistency. You can see these are not able to in extrudable format. The 67.8% was comparable with the extrudable condition. So after extruding this kind of consistency, you can use this for the kind of scaffold fabrication. So there are different gauge length they have extruded. Among that, the 22 gauge length was good compared to other parameters. Okay, so among that also they have printed with various infill density also. Among the various infill density, 70% infill density shows the better results compared to the lower infill density, because if you increase the higher infill density, now the strength was improved. So in this work, we have developed multi-materials for soundproof as well as thermal applications. So among these applications, the 50-50 combination shows better results when compared to the other among other composites. So you can see the PW, which are showing a better result compared to all other composite. So it is very good when you are using for a thermal kind of application. So in this work we have graded with various kind of lattice structure, density as well as cell size graded lattices. In metallic examples, we have used these kind of grading for these kind of cranial, not a cranial. This is a mandible reconstruction surgeries. They are using we have imported in this portion with the lattice structure in order to reduce the weight as well as without compromising the strength. Okay. So since these are some of the glimpses for the planar based lattice structure for making prosthetics and orthotics. Coming to biopolymers, we have developed patches for a wound healing application. We have mixed alginate with gelatin with some portion of drug. We have loaded with antimicrobial drugs, and we have mixed together with the alginate and gelatin, and we have extruded. Sorry, we have mixed the ink, and we have used this kind of mix with that direct ink writing method. We have 3D printed. After printing, we will put this into a cross-linker solution. After cross-linking, these kind of patches can be tested with all bio studies, strength, everything we have analyzed. So coming to application, there are a lot of applications are there. First one is prosthetics, the second one surgical, then implant, and the medical models. So these are the various orthotics and the prosthetics. So these are the surgical instruments. Then these are the implants, this is a cranial implant, this is a mandibular implant, these are the screws where you can use these kind of things. These are the scaffold, these are the pelvis muscles, everything you can use these kind of things. For medical application, you can use it in for various kind of anatomical pre-surgical models. Everywhere you can use it. So for denture making, aligners, spinal fusion cages, crowns, screws and nuts, everywhere you can use in healthcare. So this is the thing I have already discussed with you now. So this is one of the research team from the Wake Forest Medical Institute. They have developed the ear, finger. You can see this is the ear model. This is the finger model. You can see they have developed lot of organs. Okay, so coming to the scaffold also, they are using PEEK material. They have developed the scaffolds also. Okay, in food packaging also they have developing lot of things. For drug delivery, they are using various kind of combination. They are using with various kind of, for if you are going to take pills from the doctors, based on the prescription, in future they are giving you to based upon the drug composition. They will mix the dosage will be mixed together based upon the age, certain condition. They will mix the drugs and they will give with the single tablet. You can see in the right corner, green, pink, orange, pink, all are why they are given with the different color, which are the color codes. What is the drug of the color? They are giving with the different color codes. That's based on the composition. You can see this layer, 3 layers they have given because this tablet which are the drug dosage was high. So like that they are giving for the sudden cardiac surgery, then drug need to be released as much as fast. Okay, like that they are giving the drug composition using 3D printing. Okay. So coming to case studies, this is one of the surgical cast. The second one is the mandibular implants. This is the cranial implant. So in the future, they are developing multi-material composite printing. This is the example I have already shown. It's a multi-material composite printing and also hybridizing. Nowadays, they are hybridizing. The conventional printing is a 3D printing. If you are developing an additive manufacture component, immediately the conventional manufacturing process to enhance, to improve the process. Okay, like that they are mixing together with the conventional with the additive manufacturing process, or they are combining both different types of additive manufacturing process in single one go process. Okay. Then they are developing a self-transforming material, which is this origami-based tunable structure. They are developing using various kind of polyjet technology. In FDM also, we are trying to mimic these kind of self-transforming materials. We have successfully developed those things. We are going to file a patent using this kind of self-transforming material using FDM technology. Then biofabrication, if you want to make your for contact lenses, now you can use DLP based printer. One of the researchers in our institute, they are doing lot of application related to contact lenses. Okay, there are a lot of things are there using this kind of biofabrication. So coming to digital models, so this is one of the activity I have planned to discuss more, but I think the next session going to start in 10 to 15 minutes, but I will tell you as much as possible. Okay, so if you want to make your own model, okay, here I have used ChatGPT. Okay, I have uploaded this image. Okay, this is my son's image. So I have uploaded this image. and I have given the prompt. Okay, this is a prompt, and you can change anything in this place. Okay, whatever you want, you can change here. Okay, you just paste this prompt, and you can convert that first image, which is a photo, to into this kind of um, model. Okay, this image. Okay, after taking this image, you need to upload this image into printball AI. Okay, this is a website where you can convert your image into 3D model. After converting this model, here I have given to give me this kind of cartoonistic image. Okay, instead of cartoonistic image, you can put the same image itself. Now it will give you the same exact image of the photo which you are giving. Okay, after exporting this kind of model, you can put it into the slicer software. After slicing, you can get your own model. Okay, after removing the supports, you need to paint. Because I don't want to paint, I have printed it in a blue color material. If you want to make painting now, if you are skilled with the painting kind of stuffs now, you can you use your painting skill to print those things. Okay, so this is the simplest step. You can just go into printball website, and you can just upload your image, and you can have various kind of model settings are there, and you can set those things, and you just convert image to STL. Now you will get your own STL. Okay, so those who are want to make more collaboration or research kind of activities, you want to do any kind of things related to 3D printing, if you want to any facilities related to characterization, testing, or fabrication, or design and simulation kind of supports, now you can contact us. This is one of our startup. I am a co-founder of this startup. Okay, please feel free to reach us. Thank you. Yeah. Any queries, please? If you don't have any queries, means
Yes. Participants are requested to clarify your doubts.
the scope in polymers, how to select the product, and how to claim the product used for the application based. The scope in polymers, how to select the product and how to claim the product. I didn't get your question. Can you tell me what you are expecting? I didn't get you because like select the product, how to claim the product. It's for the application based. If you want to make product, mostly you will select your product which are which application you want to going to use. This is the thing you should consider. Material selection is based on the application only. If you want to make a implants, now the material should be biocompatible, biologically compatible, and it should not degrade based upon the external application. It should not be it should not be biodegradable, because if you want to make a devices, okay, for a simple example I am telling you, if you want to make a devices which is related to hearing aid, okay, the material should not be biodegradable. You can't use PLA. So based upon the application, your material needs to be selected. So if you have a good knowledge in material selection, now you can that is the main thing for making those things. Okay, any automotive parts can be selected for the application purpose. Yeah, they are using nylon. For nylon, they are using a lot of automotive parts, and also onyx printer, okay, which is a carbon reinforced nylon, which is called onyx material. They are using for various kind of automotive things.
Yes, you can type your clarifications in the chat box. It will be clarified. So there is a question.
For spray, can I redesign and clean this? Yes, you can take photo of the car wiper. Just upload it in that chat GPT. Okay, chat GPT itself, it will give you the best design. After getting the design, you can modify the design. Okay, so you can check with the dimensions. If the dimension exactly match with your dimension, now you can use the same dimension, or else you can check with the commercially available wipers. In internet itself, there are a lot of STL websites are there. Okay, so you can go with those website and you can check with the things, and you can print it with better materials, not with that PLA based one. The material should be. I have yesterday I got to discuss with you related to ASA, PCTG. The metal which should be a thermal resistant, it should be UV resistant. Like that, you can consider based upon the property and the application. You should select which material can be used for those applications. Okay, the material should bear certain loads. Every time you are going to give that kind of load, now that is like a fatigue loader. So these kind of things you need to consider. It's like a personal use, pa. You are not going to violate any company design, okay? For your personal use only. If you want to make, you are going to spend money now. You can buy, you buy your buy the kind of wipers, okay? Nowadays they are 3D printing the 3D printers, okay? All the components they are 3D printing for the 3D printers. Okay, any other queries? Currently, I am in Saudi Arabia, pa. That's why I have shared my mail ID. If you want, I will share my number. You can call me through WhatsApp, okay? Any queries? Can you elaborate on STL file repair using softwares like NetFab or Mesh Mixer? Yes, Mesh Mixer is one of the best tool, but it's an open access tool only. You can use Mesh Mixer for correcting lot of corrections. Like initially we have done segmentation correction itself. We have done with that Mesh Mixer only. But the problem is for some kind of CT and MRI data, it is somewhat difficult to using Mesh Mixer. But other kind of other kind of stuff, it is easy to use Mesh Mixer. I don't know about NetFab because I am not familiar with NetFab, but I am somewhat familiar with Mesh Mixer. Can we finish the session, sir?
Yes, sir. I'm getting to no further clarifications from participant side. So my sincere thanks to Dr. Sabrinathan for spending his valuable time with us and providing a lot of research concepts regarding to composites, 3D printing of composites with detailed case studies. I thank you, sir.
Thank you, sir.
Yes, sir. We can end the session.
Yeah, thank you so much, sir. Thank you so much for the organizing committee as well as participants. Yeah, thank you so much, sir.
So participants kindly take 10 to 15 minutes break and rejoin to the session at 4:50. The session 13 will be started at 5 p.m. Thank you.
Sir, Rajesh sir.
Yes, sir.
Sir, before assessment, kindly share the application center application number.
Which one, sir? Which application number? I can't get you.
In ATAL FDP, the assessment will your schedule is at 6:30, no?
Yes, sir.
Your center application number will be there. It is not showing in site ATAL site. Or
So
maybe
we are going to share one Google form. There you can answer it.
not in their assessment site, sir.
No, sir, not in the site. You can answer through the Google form.
Okay.
I will have the link.
Okay, sir. Okay.
That marks will be entered by myself.
Okay. Okay.
Already we have took attendance for the last 5
Yes,
days.
sir. Yes, sir.
We have considered everything.
Okay. So
There are
test
two
will be
options. Directly you can write. Otherwise, the coordinator can
yes.
enter your marks.
Yes.
We are going to make
Assess
assessment. And we are
yourself
going
in the Google form. Okay, sir. Okay.
Yes, sir. At
Okay, sir.
6:25, at 6:30, it will be shared, sir. Don't worry, sir.
Okay, sir.
Thank you.
Nice
Thank you.
program going on. Nice one, sir.
Thank you, sir.
Good.
Thank you.
Hello. Hello, sir.
Good evening to everyone.
Good evening, sir. You are audible, sir. Very good evening.
Dr. Tamilasan sir, are you here? Namaskar.
Sir, which one minute, sir. 1 minute.
Yes, sir. No issues.
Sir, my link or this link, sir, actually.
Sir, I have sent only one link, sir.
Okay, sir.
Day 6, I have mentioned day 6 and the title of the FDP.
Okay,
I have sent to you.
Yes, Professor. Okay, Professor.
Yes. I welcome Dr. Tamilasan sir for the session 13. Here, today in this session, we are going to see the optimization techniques for sustainable additive manufacturing using artificial intelligence. The last session, swarm intelligence, was very effective and very useful for all research scholars. Thank you very much, sir.
Thank you, sir.
Now I kindly request Dr. Tamilasan sir to start session 13.
Okay, sir. Hello, all. Is the screen visible? Hello.
Yes, sir. Visible, sir.
Okay. Thank you, sir. Very good evening to all. So thank you for your introduction, sir. And we already know about this. So this is second section for me handling on this topic. See, as we know already discussed about the past 5 days about the in-depth basics of additive manufacturing process, various types, everything we discussed. Oh, 1 minute.
Sir, it is visible.
Professor, kindly check. Thank you.
Yes, sir, it is visible.
Yes, sir, put thumb symbol. Okay, so we go for relevant to the title, we go for to discuss further. Sir, as optimization techniques means we find the best feasible value to feed the machine. So most of the work done by conventional process, like traditional machining process, machining, drilling. I don't want to go for basics of additive manufacturing process. I want to talk about that recent work going on in this field and which work I have done in this area, which work I am carrying out in this area, that kind of things only I'm going to talk about this relevant to the optimization techniques. So as I come to, I know that I am familiar in this. I understand that some of them may be experienced in the field, attending at ATAL workshop, as well as some of them new in this area. So whichever, some part may be useful those who are experienced in this field. Okay. Coming to the part of optimization techniques, there are many optimization techniques that main agenda find the best value, feasible value. So start with the machining process and start with normal that is machining, drilling, whatever the traditional machining process. Much amount of the work carried out by the different researchers in the area of which one conventional optimization technique. See, we start from always optimization design of experiments, full factorial design. We call it as first one full factorial design. Then second one fractional factorial design or maybe on Taguchi design. And the third concept referred as the response surface methodology. So where we develop the mathematical equation. So further we are having the different types is central composite design, and for box Besant design, then D-optimal design, then blank permanent design. So many designs which are available. So which one more suit? The researchers always suit for the selected for the best experimental process to carried out in a particular process. And moving over some research papers in this field, connecting to that some advanced level, like 1 era. Just you think on past 10 years, people used for the algorithmic based optimization approach. Start from mother of all algorithm, we call it as genetic algorithm. So genetic algorithm, real coded genetic algorithm, and for micro genetic algorithm. Then next started with particle swarm optimization algorithm. There we have the different divot route, and for next firefly optimization algorithm, and for ant bee colony algorithm, artificial bee colony algorithm, Kakabora, that introduced that algorithm. So like that, many number of algorithms widely used by the traditional machining approaches. Respected attendees, and this is not only focused on only on alloy material, so applicable applied for alloy steels and for fiber, that is natural fiber composite, metal matrix composites, widely used. The recent topics, as I am that reviewer, many journal, I am receiving many papers in the field relevant to the latest one. I think subractive manufacturing process still competing to this, which one, sir? That is additive manufacturing process. So we are going to introduce the new kind of AI techniques for the technological impact. We are going to introduce the new kind of techniques. So further to boost, to find the best of best optimal value. So instead of the interpolation, we go for the extrapolation, go beyond. That is why we call it as always a meta heuristic algorithm. So meta heuristic means go beyond the limit to find the best optimal value. So like this, we have discussed last session, I think third session, we discussed swarm intelligence algorithm. So I shown you many number of different algorithms. So if you are interested, I already that is passed this information, means you can use for any amount of algorithms. So okay, sometimes you take 6 algorithms, or sometimes you take 4 algorithms, just you take for your comparison. So again, these are the hot topic in this field for doing the better optimization. Optimization alone is not important. Along with that, we need to add some suitable amount of images to validate, like SEM, EDAX, and other kind of things, which will chances for the publication. So that is what to arrive the best results. These are the algorithm. Hopefully you may be referred. I will share this PPT, or may be available in the internet. If you are trained in this field, then you can go for to design one more algorithm. After 2 to 3 algorithms you trained, you can design by own using any amount of large language model. Okay, this is what going on at present. Then connecting to this optimization algorithm, we want to tune further. So for that, we use for some machine learning techniques. That is what here AI connected. So you are seeing on right side, these are the methods. We know commonly the graphical method illustrates the metal extrusion, additive manufacturing related images. You are viewing DED process. Already these things you familiar. So where we are going to add the which ones are machine learning approaches, like supervised learning, and for second unsupervised learning, and for semi-supervised learning, and for reinforcement learning. These learnings network to prepare the best network to tune further about the which one the algorithms to yield the better results. So where we implement these kind of network learning network means we adopt in the additive manufacturing process. So this way we use for the basic of which one ANN we know. So further we have different networks at present available. So like that, we go for to discuss one. These are the advanced. I'm sorry. Okay, advanced machine learning models. So now, like we call it as nowadays a transformer model. So where we adopt the self activation to tune the best results. So by tuning of these embedded with these machine learning algorithms to the optimization algorithm, which yield the better results. So which purpose we use? We know that quality control. Excuse me. So these are the purpose we use for these are the algorithmic approach like quality control, and we know all the terms, material formulation, process optimization, design optimization. These are the purposes we are using for this, and we use for the microstructure optimization also. So for microstructure optimization we use for additive manufacturing process. People nowadays used for the deform 2D 3D finite element software to predict the microstructure of the existing component. Okay. Then we go for that some component moving forward. So these are the publication till 2022 published in the area of additive manufacturing process. So that stacked bar chart which shows the different components like powder PBF process, material extrusion process, metal jetting process, like that. So there are wider scopes available nowadays. Most of the papers I am receiving as a regular reviewer, many papers in this area. So it is a hot topic. Maybe if you are interested, please work on this area to get good amount of research knowledge. Okay, and these machine learning applications widely applicable for different areas. Like start with computer vision process. So I go for this. Just you take this computer vision process. So the components are fabricated like in our additive manufacturing process: filament diameter, filament spacing, layer by layer we fabricated this component. So we convert this into images. So to generate the image histogram, to identify the how many number of pixels exist, then we may measure these quantum of items using the different kind of image processing techniques. See, I recommend different methods for segmenting these images. First one called as the thresholding process, bi-level thresholding and multi-level thresholding, and for edge-based methods and region-based methods. So among these, most of the popular method till we are using for the thresholding method. So some objects foreground, some objects on the background to segment the image by using the optimization algorithm. Like that, if we segment, then what happens, we can identify where that defect which are exist. So like this, if you adopt this machine vision approach, we can easily to predict in that is during the manufacturing process. So these pixels are removed, some unwanted pixels are removed, then the pixels are synthesized by means of the different operator, like a canny operator, subel operator, many more operators are there. So in this work we carried out that canny and subel operator to optimize this pixels. So that is why we used for the machine learning application in additive manufacturing process using computer vision. And probably most of the work going on prediction of the different mechanical properties like tensile strength, compressive strength, and for fire strength, so impact strength, so many strength we predicted using the machine learning approach. The machine learning that is embedded with the optimization technique to yield the best value. Like that, we go for the semantic, one by one we will see semantic analysis, and for NLP, natural language processing, and we use for that is to see the send the command through the voice, the system to understand, to do on which way to fabricate the product using the NLP process. And for data interpretation, then information retrieval. So these purposes we are using the ML domain in our additive manufacturing process. Then coming to this, in any of your AI, if you introduced, this is the general architecture behind main role for identify to perform the optimization work. For example, this is your additive manufacturing environment. So best value you may find through the formula through the fitness equation. This is directly connected to your evolutionary optimization techniques, like latest optimization techniques, lion optimization, crocodile optimization, all animals related optimization techniques. And for teaching learning based optimization techniques, character based optimization techniques, lecture based optimization techniques, many of the optimization techniques which are connected. Then these optimization techniques directly assembled with which one, like the network architecture. Here we have machine learning, different machine learning models like assemble learning methods and non-assemble learning method like LSTM. So many techniques: XGBoost, NGBoost, CatBoost. So many architecture we may develop. This architecture directly implemented means some weakening network is created. So that what we do, we need to go with the first evolutionary optimization techniques. These techniques embedded to fine tune further to best the optimal weight. Then further, if you feed that, the system will work to remove the appropriate error. So this is the general idea behind on identification of the AI based optimization technique. So here we are performing the optimization based on this. I hope you understand. So this is the common flow chart. Start with always your parameter, and for pre-processing of your data, so you have to generate sometimes data, or you can download some data from the internet resources. Just I'll show you some part of data set now. So this is the data set. This is the data set which we prepared. Which we downloaded from the GitHub file. For example, printer speed, they given here in our additive manufacturing process, and for extrusion temperature, and for thickness. So all that things they given. So first factor, first process parameter, print speed, second one extrusion temperature, and the third component referred as the fill density percentage wise, and the thickness of your that is your layer, and for your orientation of your direction. So by performing this, so that author developed nearly by carried out 150 number of experiments for predicting the which one data, that is a tensile strength. So we take this data set for performing the optimization techniques. Either you can go for prediction of the parameter, or you can go for the which one optimization route. So whichever the route you can go for. This is what the data set file on preparation. If you are doing real amount of research work, suppose some research, as our professor Rajasekharan sir told, that some research scholars are there. So if you are doing research level, you generate some small amount of data set, not this much amount of data set, a small amount of the data set you will prepare and do your research work for prediction as well as for the optimization work. So coming to our slide of this pre-processing, any data missing, or if it is I think here some categorical data which are exist, likely you look on in this only numeric data which are exist. Sometimes categorical data like orientation, xy, yz, zx, some amount of categorical information exists in the column means, then you go for the minimax normalization process to normalize your values. That is commonly we to perform. So we have the formula here, minimax normalization. All informations are available in the internet only, so you can go with directly to prepare this. So using this formula, we may do this which one, sir, that categorical data convert into the numerical data. That is what we do normally here. So next, AI model development. As I mentioned already, you can go with model development. Start with different model, assemble models, or different machine learning models, or maybe on deep learning models like CNN or generative adversarial network, then RNN, recurrent, that is recurrent that neural network. So many things are existing here. So like that, you develop the model. These models, if you derive directly, there are some weakening things that exist. Therefore, what we do, we adopt some kind of optimization. In this picture, only they mentioned like genetic programming, genetic algorithm, PSO, ABC. These are very old. So you may use for like latest research algorithm, latest better swarm search algorithm to fine tune the model. So computational tuning and testing the model parameter using the optimization algorithm. Here the AI connected here using different techniques like hyperparameter tuning done by normally 5-fold cross validation, or maybe a 3-4 cross validation. Once you fine tuned, optimal model achieved. Once the optimal model achieved means, then you whether the optimal model whether strong or not. So you can get it through the different statistical parameter. As you know already, for RMSE, root mean square value, mean average error value, then for kappa static, then for F1 score, and for mean square error value. Like that, you understand, identify the different statistical performance test if you carried out. If these quantities are nearby one, sometimes minimize or sometimes maximum value reached, means your optimal model is correct. Then you can go for to predict any quantum of number. It is like similar to mimicking of fuzzy logic as well as a neural network. But only thing here, we better strong reliability of this work, we go for the AI to introduce. Then this is what I mentioned here: data collection, data generation from our that is additive manufactured component, data collection. Then we use for the databases to store. So here, as I mentioned here, where is that the data are collected from the machine. Then I am observing here any by randomly looking on this, no error found. So I think around nearly by 150 data is present, except the first row. I think 149 data are present in this. Then for afterwards, what to do? That is always this one more reusable, used ready to start with many researchers for performing the further amount of the existing work. Then we are going to do the data cleaning process. Sometimes noisy data, sometimes typographically we put some wrong error, sometimes tenses mentioned a negative number. Like this, we need to clean the data. After cleaning the data, we go for the model building, that is I mentioned here. Then based on the domain knowledge, then whether the model is correct or not, once if it is achieved, then again feed to the mission to like a closed loop system drive to make the perfect operations of additive manufacturing process. This is what normally going on here. We adopt the optimization algorithm. Then here the data are very large. The data are in very large when you connect with the AI. Normally people say here 3 Vs, sometimes 5 Vs, sometimes 7 Vs, but normally we cover here, we understand first of all 7 Vs for this is connected with the big data analytics. So volume of your data, that is immense scale of data quantity, how much volume. Suppose if you use some RSM method, your data set very less. Sometimes randomly, if you carried out by adopting with the lower and upper bound, you can generate many number of volumes. Then for data, higher velocity is needed, rapid data to generate. Your machine learning algorithm easily to respond. If I touch on your body, immediately responded. Like that, your data to be responded very well with higher speed. The next data may be on different varieties. Sometimes numerical data, sometimes non-numerical data, sometimes category data. Like that, different data varieties are there. Those data are also involved in our data set. And veracity in the sense, accuracy and reliability of data. Just I downloaded some data set from this some like Gaggle or somewhere here. First of all, after performing the different optimization techniques, I must understand these data are correct data. Anyone generates sometimes wrong data. For example, I am going to generate one rank data, rand between just if I feed this one, if I feed the data generate 30 comma 56, if I'm asking to the system immediately to generate the fake data. Okay sir, so anyone can generate different data. So that the data veracity much more important, the reliability of data very much important. Okay, accuracy and reliability of data much more important. Then next, extracting useful information from the machine, that is very important. Unwanted data, if you generate, the machine learning algorithm may be confused and you can't reach the better R square value. And sometimes variability in the data present. For example, inconsistent means the combination of numerical data as well as categorical data. These data are sometimes even minimax normalization method also not adopted for converting the normalization process. Then we go for principal component analysis, different techniques to adopt the variability. That is also involved in our data set. And visualization in your because why these are the things are much more important while handling the data. Maybe on sometimes in your additive manufacturing process data, if you download from Gaggle or somewhere, around by 10,000 rows, 10,000 maybe on 10,000 columns will present. Those data is handled by our machine learning algorithm connected with optimization techniques, that time very difficult. So all these 7 V's are considered in better way. Once you understand, once you these gates are clear means, then you go for your prediction process. And the next, model complexity. So model complexity in the sense like whether shallow or maybe on a deep level. So normal networks in the sense, normal network in the sense like shallow one. whereas in deep network means like deep level to work on. So for that we have further parametric and non-parametric. In the parametric we have linear regression, polynomial regression, ridge regression, logistic regression, many more SVM models which are exist, that we will see one by one. Next, non-parametric in the sense nearest decision tree based, k nearest neighbors, k mean clustering, PCA, then T distributed stochastic neighbor embedding. So these are the process to deal on the non-parametric one. That is your model complexity. It's just dear all, just you think about that our brain, how it is work. For example, Janagana Manakati song, we are playing from the childhood. So we deeply memorized that. But yesterday, if we given lecture in our classroom, today we remember, next day we remember, after 10 days, maybe remember, after 1 year, that is not possible. Like that, you think on the model complexity of our brain. Then in this case of deep learning, so we have a normal ANN, like a multi-layer perceptron based one. So this normally most of the people done in this field, but remaining two are current topic, like CNN, convolutional neural network, and recurrent neural network. So these networks are widely adopted by additive manufacturing process nowadays. So if you are interested, if you develop some code and generate the network using OpenCV or any other Python code, or maybe on Jupyter based, some notebook based, if you generate, you will achieve good amount of your result. Then the data may be on first column, tabular data, spatial data, sometimes images to process. Likely I mentioned here, here this is what my input in my process. I may convert into the open, bringing into the OpenCV, then I may use for different operator to minimize this. So what we do here, that is spatial images present sometimes, those data are spatial data. Then next one, spatio temporal data, like video data, simply we call it as sometimes video data. And for last one, sensor IoT or biomedical based IoT enabled sensor data. So these data sets, I told you again, I told you already, one on small data set and on the large data set, then connected through the different network model choice. So for polymer, for performing the polymer additive manufacturing process, these are the main that is task. One on property prediction, second one process optimization, and the third one institute monitoring process. So for that we use for the these are the network structure. Respected all, if you adopt conventional neural network or recurrent neural network, these network if you use, sometimes maybe you will get some struck. So that time we use for some essence of optimization algorithm, which will boost the better result to reach out to all three components of green color they mentioned: property prediction, process optimization, and institute monitoring process. Then go with one by one network. So this is called the first image, which represents the our normal artificial neural network. So already familiar, some of them this area artificial neural network. That first yellow red color represents here input layer, last referred as your output layer to predict your output features. Then middle gray colors referred as here your our hidden networks. So we may do here using MATLAB. Generally we use for most of the researchers, they used for the MATLAB, and different online neural network softwares are available. Just you can feed the data using this to predict your output. For Scopus index publication in additive manufacturing process, that A network you may use. In case of recurrent network, again use for the same data, but continuously monitoring process. Like we feed the sequential data, and for to get our additive manufactured quality using the recurrent, there are some weights always activated in the hidden layer. This concept referred as the recurrent network. And for last third one referred as your convolutional neural network. Here convolution in the sense, suppose for example in the additive manufacturing process defect identified, so capture the image from this, then this is what, wherever you see this is what we say here kernel. The kernel manipulated by different amount of the convolution, and again different convolution layers which are produced, then each layer arranged by column wise, you convert into row wise manner, then feed the network through the fully connected layer, which will yield the good amount of. So A, B, C's are better performed than the multi-layer perceptron. Okay, so because we are using the different bounds of method to yield the better result, but here numerically only we will deal, but the B and C we may use for images also to predict to identify the defect to the system. And this is the general image which we captured. Input images, suppose we want to produce some images, some FDM or additive manufacture component like this, then using the CNN network structure, like different pooling layer, finally using that component identified and predicted through the which one, that CNN network. So this is the prediction of the ground truth level. So for that you can use Python, OpenCV, so many more, and for MATLAB you can use for this. I won't recommend normally MATLAB for performing the prediction of these parameters. I recommend strongly on Python because more easier to understand. So this way the ground truth level. Okay, but compared with that, there are certain differences will be noted, as we know through the like qualitative methodology. If you see through our normal eye, there are some slight differences will be there between the input and the predicted ground truth. So that where we implement some amount of, we are going to introduce some optimization algorithm that I will show you. Optimization algorithm, when we introduced this AM component, further the component prepared in the good way, good quality and good strength. This is what the overall view of your CNN network. And for next, as I mentioned already, this is the graphical representation, that is learning of your data set, training your machine learning algorithms with a variety of potential models, as I mentioned, then evaluate your data set. Then by using this, you go for the two variety of methodology. One on the hyperparameter optimization. This is very, very important. There are many parameters are influencing our network, alpha, beta, gamma, number of layers like this. So this way we do fine tune further different optimization techniques. Once the model selected, then we go for your prediction. The models are evaluated through the cross validation approach by essence of the four methods, like region under curve, AOC, then area under curve, this one performance measures, then F1 score, then recall, then precision, accuracy, capacitic, many more model evaluation properties are there. Numerically you may obtain, as well as graphically also you to obtain. Then these are the different performance metrics, as I mentioned just 15 minutes back: coefficient of determination, mean squared error, mean absolute error, root mean square values. So these are the performance metrics. If you get it, these values to be showcase the proof of your predicted model. Okay, so this is the example where I mentioned here how to do the cross validation. So cross validation in the sense like preparation of the that is perform the trial and basis method. Okay, so normally the people first they start for train the model, then validate the model, again train the model, validate the model. Like that they go for n number of times with different parameters. Number one, likely they go for number two, number three, number four, like that. The machine almost trained by the cross validation, like changing of the parameter on different basis. This is normally we do in Python. Once if it is completed this data, then you will get the best output of your trained model. So today I am singing one song. Next day, next 10 days, if I practiced, fifth day I ready to sing a song in good amount of pitch and tone. Like this we do for our cross validation. This is much more important in any prediction of your parameters. Then here I recall this machine learning. Supervised learning means that is supervisor mandatory. For example, in classroom, this is commonly the people say this example. Supervised learning means teacher acting as a supervisor, the student learning in the classroom based on the instruction given by our faculty. That is what supervised learning. Unsupervised learning means the faculty not present in the classroom, selfly they learn. Okay, this is called the unsupervised learning. Then third one referred as in the combination of both supervisor and unsupervised learning. Just you look all in supervised learning, regression, decision trees, random forest, gradient boost, GBM, SVM, neural network, Bayesian network, K nearest neighbor, KNN, many more supervised learning things are exist. But you can use for only some amount of weakening will exist, supervised learning process. Shortly we may do process fast because some supervisor to control this. Whereas in unsupervised algorithm like hierarchical clustering, then generative adversarial network, then ICA, PCA, self-organizing map, unsupervised learning, selfly to learn based on the data given. So that this process is somewhat very difficult as compared with the supervised learning process. You can't achieve the best value, so fine tune further by using the which one cross validation purpose. At last, very good topic as my point of view, reinforcement learning. Like we say normally we are in mechanical background, reinforcement, that is reinforcing composites. So the same concept here we use for reinforcing the learning process, like Q learning, that strategy called Q based formula. According to that, deeply studied means DQN, deep Q networks, where we have the agent, and for rewards, episodes, we will see one by one. Then PCM method, policy gradient methods, actor critic methods, deep deterministic policy gradient method, multi-armed bandit algorithms, Monte Carlo tree search, model-based recurrent net learning. So there are many more methods, many papers, records ready to publish in these areas. Suppose if you are adopt these kind of things in your additive manufacturing process, means probably the paper may be chances for the publications. Okay, we know that supervised learning we understand, unsupervised learning we understand, with supervisor, without supervisor. And for this is for the general representation of better understanding of which one means reinforcement learning. So here this is your agent. Normally ChatGPT, one of the agent to deal any amount of discussions. My mobile phone, one of the agent to see all the data, like that conversational agent. My laptop acting as one of the agent to see all those things. So this agent to perform some action in the machine. For example, I prepared one chatbot. I prepared one additive manufactured chatbot. I am going to convey the machine to that environment of additive manufacturing process. Like a voice command, if I feed the system to prepare instead of the manual feeding of your additive manufacturing component. Then once your component fabricated, there are two things we will get it. One on the state one, which state the component now ready to fabricate or fabricated the state. The state attained means the agent okay, they feed the data. So if this state perfectly done means we put one reward for this. Like always, the reward much more important. This parallelly going on in artificial neural network. We say wait, here we say here reward. Sometimes we say the episode. In episode, we say sometimes the alternate word called as the episode. So like this, we train the machine many times in reinforcement learning. Your that FDM machine or SLM or DED, whichever the machine, once ready means through the voice command we will prepare. So this agent, this action performed by our in the combination of hybridation of which one, machine learning, deep learning algorithms plus optimization algorithms, the environment to work on this way. Okay, then I go for one component, like this is the general idea behind. For example, our component prepared some amount of FDM layer we prepared. So one layer we take, so filter the responses using some techniques, ML based techniques. Okay, this is the layer of a component produced maybe on FDM machine. Then these pixels, the image computer vision, image processing, they performed here, identify the number of pixels. Then the pixels are clustered into different categories, higher gray level, lower gray level. According to the pixel intensity, the amount of cluster exists. In case of K means clustering, if you take, there are K cluster, there are 4 clusters, K equal to 4 clusters exist. Then we go for the, we identified this number of clusters here 3, number of clusters 4, number of cluster points here 2, and for this is 3 and this is for 3. For this cluster point, the directory generate like some words. Okay, this area some defect. Dear all, just you see my profile of my cursor movement here. This is word number 1. In this situation, word number 2. In this situation, word number 3. In this situation, word number 4. Like this, the directory prepare this. Okay, this area good, this area moderate, this area some defect. For example, you can see here my cursor. Here this area somewhat defect, this is identified. So this is what trained by, as I mentioned in our ML model, NLP, that is natural language processing. How the words are prepared, how the words are processed, where the defects are very high. Further 2 to 3 slides we may look. This is what the natural language processing. One of the shake of example, that n equal to 1 referred as the unigram model. Second one, n equal to 2 means bigram model. Then third one referred as the trigram model. For example, here I take this is a sentence, means this is a sentence. If I deal one by one, that is unigram model. If I take two sentence, bigram model, this is a sentence. And for next trigram model means three words you take. This is a sentence. Like this you take. So in this way, that in the directory, the machine may take this component failed, this surface not in quality, this surface good in quality, this surface, like that the system will prepare that directory of word from this. Once prepared unigram, bigram or trigram model, then we go for the TF IDF calculation. TF IDF in the sense term frequency inverse document frequency, which means that how much amount of importance term which are existing in the system. I go with that the sample calculation. For example, that in case of this additive manufactured layer, word 1, word 2, word 3, we treat it in language processing while generating AI based one. We take this that is document 1, document 2, document 3, document 4, document 70, like that we prepare. So the sample of example, I am going to take a document 1 and document 2 and document 3. Instead of the additive manufacturing process, for better understanding, I pasted here this document. A quick brown fox jumps over the lazy dog. Document 2, the lazy dog slept in the sun. Then third document, the quick brown that is brown fox sat on the mat. Likely, dear all, you take the different word. This quality of the future quality of the layered future good, like this. The second sentence you will prepare like this. Like this, once you prepared, you calculate. Here are just you see this. The first document 1, we are processing through language processing of AI. The how many letters present? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 letter present for document 1. The how many times exist? 2 times exist. Quick how many times exist? 1 time exist. So the numerator which contains how many times the word repeated divided by total number of word present in the system. Like that, brown 1 time exists divided by total number of words. And the fox, the word 1 time present, jumps 1 time present, over 1 time present, lazy only in the document 1. Like that, in additive manufacturing process based component, in the directory, the system prepare like this. This is the surface good, this is the surface bad, this AM manufactured surface good, like this moderate, here that area defect, like that the system identify. We you to prepare the document like this. Once if you completed TF, that is previous, which one sir, TF of this, then we go for the IDF. IDF equal to n divided by n term. N referred as here how many number of documents you are going to process. For example, in the shake of example, capital N equal to 3 documents process. But in this research paper, 70 documents to process. So for better easy of understanding, I am going to take the example to continue. Capital N equal to 3 and n term referred as here. How many times the letter presented in this document? Like this you calculate. For example, I am going to take the letter of first letter, the letter. The letter I am going to take. The letter is the word, not letter. The, I'm sorry. So the word present on document 1, the word present on document 2, the word present on document 3 also. So that 3 times it appears in all 3 documents. Therefore, n that is a suffix item the is equal to 3, like this. This 3 refers capital N, number of document. Then quick referred as quick appeared in document 1, quick appeared not exist in document 2, quick appeared in document 3 also. Therefore 2 times exists. Therefore 2 times it appears the 2 times. And brown exists 2 times. It appears documents 1 and 3. And the fox appears 1 and third document like this. Like that, the component processed. This is what IDF. Then, as the statement given by natural language processing through AI, then you multiply this statement TF and IDF. If you multiply, what happens? We will get some value. For example, this is the calculation of only IDF 0 log of 1.5 log of 1.5, like this we got it, and we multiply this term. While multiplying the word TF and IDF, if you multiply 0 exist, means that word not significant. Like that, if you go in this 1 by 9 into log 1.5, 1 by 9 into log 1.5, 1 by 9 into log 1.5, 1 by 9 into log 3, like this, which number numerically high means that number, that relevant word more significant, more important to feed the machine to better to understand through the AI system. So respected attendees, in this 70 documents processed through the natural language processing through NLP and the AI, any amount of AI system, the system understand where that failures are occurred. For example, in this zone occurred through the NLP, the system may process this process this area identified. So like that, the words are worked out and histograms are prepared, then table of fingers are prepared, then finally the system identified the words, which one is more important, which one is less important. I think these area of words are more important to identify the weakness of your product, automatically conveying to the machine immediately to understand through the learning process, then to identify, to prepare the remove the such a kind of error for the next stage of your layer process. I hope you understand this statement. Okay, these are the different things exist. Then based on this work, some of I'm carrying on different amount of research work. This is one part of our research work. Now 2 major revisions are completed in surface reviews and letters in World Scientific Journal, so very soon to publish. So this paper I'm going to discuss based on this. The title here: predicting tensile strength of 3D printed parts using Kookaburra optimization algorithm enhanced with the XGBoost algorithm. So here XGBoost referred as the different one of the machine learning algorithm. Then Kookaburra optimization algorithm added here for increasing the strength of the XGBoost algorithm to predict the better values. So this is the bird of Kookaburra. So this is the VOS viewer to identify the how many number of researches they worked out in the field of machine learning based additive manufacturing work. You can see this, you can plot through, refer some YouTube video, you will develop this one. I think the blue color, the red color and the green color networks which are connected through the random forest, mean square error, this is complete map. Instead of literature review, this way if you present means the chances of reader to accept your literature review quality rather than typing of different number of paragraph. Once you completed this network connectivity, there are many ways to network connectivity. Yes, huge number of work commonly compared with that orthogonal, experimental array, nylon and toughness, polyimide, many work carried out. But we understand there are some challenges present in the area, which area, like machine learning and different optimization algorithm. So I hope you understand this concept. Then we go for one video. First of all, before going to start this one, going to demonstrate like a Kookaburra optimization algorithm. So before discussing to this, just I typed KOOKA. Remaining things are exist because of the language processing, bigram n-gram model. I hope you understand this. Whether you may view this one of the image of video of this image audible, no problem. Okay, so this is the behavior of the laughing behavior of the kookaburra. So according to that, the researchers worked out the author developed this algorithm. The researchers, they developed the kookaburra optimization algorithm. So this is the algorithm. So very nice attempt they proved by the author. If you are interested, you may adopt this kind of techniques in your research purposes. Suppose if you are working on advanced level, you develop your own algorithm or implement some other strategy. For example, here the keywords are mentioned, as already mentioned here, exploration and exploitation much more important. So coming to this, the author developed this kookaburra optimization algorithm. They given a theory. The behavior of the kookaburra laughing and as usual attacking these, which ones are eating the insects, some amount of varieties. And always start with any algorithm. It's like which ones are generation of the your values, like randomly to initiate your kookaburras. The position of kookaburras very very important. So the author mentioned here, respected all, looking on this equation, you don't feel any tough. So today you have the chat GPT to generate your code. Just to generate your code according to that, visualize through MATLAB environment. Then by the way you try to understand. So MATLAB is easier on simulating of optimization algorithm. So this is common, and n by n m dimensional. And for this is also common by generating through the lower bound and lower bound and upper bound, generating through the random number. So this also be common for any algorithm. If you generate line algorithm means number of lines, position of lines. If you generate peacock algorithm means peacock positions, you may note it down. And for if you introduce monkey means monkey, like that you work on this. And these are common, and based on that x1 x2 x3 x4 values, then generate the which ones are respective fitness function vector that you generate through this equation. Okay, for example, to 500 numbers, if you 500 rows, if you generate 500 rows of objective function, which will generate. So this is common for any algorithm. Just I mentioned on here, this is common for all algorithm. So once you completed this, then hereafter our work start. The phase one in mathematical modeling, first of all I told you already, exploration, and for next exploitation. So in this exploration, the kookaburra, it's like a bird they given here. They developed the mathematical equation, the composite objective function. These are we will develop whenever xk a function of this is the equation where k does not equal to high. This situation you take for this. And equation 2 referred for operating through the random number using the some index values. Like this we process of equation 5 and 6 for performing the exploration activities. Once exploration over, you to set by some different, including in the equation by setting of some random numbers. For example, I the author taking here 1 comma 2, you take the random number, any random number. And the number of kookaburra author taking 5 means you take for 100, no issues. Like this you go for this one. Here r is a random number with a normal distribution in the range 0 comma 1. You can use for Poisson distribution. Like this, if you take algorithmic approaches, different way you can observe. In case of phase 2, once you completed, you in case of phase 2, ensuring the prey is killed or not, that action called as the exploitation activity. So like this the author prepared the better equation. Finally they completed this one. So once this condition satisfied, both exploration and exploitation, repeat the process until the that component, that insect may killed. Once if it is completed, the process is over. So for that the author introduced this computational complexity This is very, very important in any algorithmic procedure. As I already mentioned in our previous slide, whether you remembered or not, just 1 minute. Yes. This is what very, very important for any algorithm like O formula. O formula referred as your problem definition plus your problem initialization plus your function evaluation and your position update strategies. If number of components very higher means that algorithm not converged in sufficient time. Therefore, initial level of beginners, you work on very limited number, 2 or 3 dimensions you take and work on initialize your problem definition, function FE, and for position update strategies. Then once you trained are 500 or 1000 times, then you go for which one more than many number of dimensions you can go for this. So like that, the author mentioned here the O formula in the different bases. Okay, O of n m means number of Cocoboras, m means number of decision variables. That's why if you are beginner, you take 3 or 4 dimension. Once you trained, you go for 10 dimensions. Once you, if you are in advanced level, so like that the problem evolved. Then author slightly modified this O formula nm of 1 plus 2 times the number of iterations. Once the complexity level prepared, then the algorithmic work started. This is the flow chart the author mentioned. This is the pseudocode for author mentioned. Respected attendees, use ChatGPT for developing the which ones are copy and paste the pseudocode, generate the appropriate which ones are Python code or MATLAB code. The system will generate, fine tune further. Better code you will get it. Then you implement for your any additive manufacturing process as a initial level. So always in any algorithm, this is a common problem formulation, number of objective functions, constraint, and set the population size and the number of iterations. Normally, number of iterations people set by small n, sometimes small t. This author set by capital T for show the differentiate from this. This the equation 3 common always. Initialize the population matrix. Already we discussed like that. Whatever we discussed, phase 1, phase 2, the same way the author mentioned. Once we which a bird killed immediately the bird using some tactics, that bird is a better output. By the way, we are clearly identified this. So this is what optimization algorithm. Then, as I mentioned in the title, we go for which ones are XGBoost. This is important machine learning algorithm. Extreme gradient boosting, highly coefficient for scalable machine learning algorithm. So the sequence of algorithm to make the weak learner identification. So to minimize the prediction error by adopting the different decision tree. So set of equation 3, 4, and 5 used for machine learning algorithm of which ones are XGBoost. So gradient boosting framework based system work. Then I integrated both which ones are integrated Cockabora optimization algorithm with the XGBoost for the prediction task. So my aim here to minimize the mean square error value by adopting the interlinking of which one, this assemble algorithm of this one. So while adopting this, I got different output that we will show one by one. So I told you already, before analyzing any amount of data, we need to identify whether the data correct or not. So this is the scatter plot matrix on component of which one, like with reference to the data set, like which one means in the sense of print speed, extrusion temperature, fill density, thickness, and orientation. Accordingly, that scatter matrix are developed. Almost the data are a good amount of peak and valley exist, no amount of error which are present. And we develop some correlation heat map using the Pearson correlation coefficient for better the relationship between, for example, printer speed. print speed always 1. Like that, the futures of these always common connectivity, all the diagonals reaches 1. But when I take extrusion temperature and for tensile strength, only the relationship 0.28, the fraction exists. But the print speed with the tensile strength, only the correlation heat map exists, only minus of 0.5. That contour, that color map shows that the difference of things exist. Like that, correlation map generated for this Kookaburra and for XGBoost algorithm using this. And I prepared I am going to observe prepare the violin plot. Normally in violin, the violin plot also prepared how the print speed data are prepared for the tensile strength component. I think print speed 30, print speed 40, and print speed 60, and print speed 80. Some differences will be noted, but the exact violin which are exist only on 50 normal speed. Like that, I analyzed the data set. Like that, I go for that violin plot for the extrusion temperature, and for fill density, and for thickness completed, and for orientation angle. Based on that, the violin plots are generated. These violin plots are very nicely prepared, but some weakening data which are present by analyzing this. For example, extrusion temperature, that models does not prepare much more level. Some weakening data is present in the data set. Like that, we analyze the data in combination of this. Then I analyzed the box plot data, print speed, and for extrusion temperature, and fill density, thickness, and orientation. So we are that interquartile range exactly formed for the extrusion temperature, and for all other whisker not generated in this box plot of all futures. I think this is better, and one outlier present in the box plot. Like that, we analyze the data set in different manner. This is another chart, whether normally distributed or not. So like that, we analyzed. I think extrusion temperature prepared better as compared with extrusion temperature as well as the thickness component, and almost the histogram in the different density of histogram which are prepared in the different basis. So likely we discussed numerically in this in our paper. And after training our XGBoost and Kookaburra model, the training set output almost 45-degree angle, more of the most amount of that point which are lying to the nearby the 45 inclination line, and the test data set also lies on nearby. Some gap which are exist, so does not create any amount of issues in this direction, because most of the models are trained in good level. So once you completed, we go for next component. This is the way we identify future important ranking. So print speed, which create much F score as compared with the thickness yield only 104 future importance F score value as compared with that print speed. These are the futures we may analyze through the F score values. So this plot much more important. So my aim, respected attendees, my aim here to minimize the mean square error of our optimization assembled with the XGBoost algorithm. So I took for 20 swarm size, 20 Kookaburra, next 40 Kookaburras, 60 Kookaburras, 80 Kookaburras, and 100 Kookaburras. So after selecting the different, just imagine 100 Kookaburras flying nearby somewhere in mountain. We are feeding the insect. Which insect killed by the Kookaburra? Which one is more intelligent? That way we prepared, and we feed the data of additive manufactured data. Mean square error value gradually minimized, and orange color, I think 40 number of swarms are better output we got it, because which minimized very lesser value of the all other mean square error value. Here you can see that from this convergence plot, mean square error versus iteration, within 100 iteration the process quickly completed, because the model complexity only very tough we selected, because 100 the algorithm fastly converged. The standard deviation almost very lesser value we obtained. So these things referred as exploitation. These points referred as all the starting points are exploration points. All other deviated different routes of the swarm size, we call it as the that is exploitation route to find the best. Just you take some another shake of example here, like which one? Even if you take the orange color, exploration and exploitation, some amount of iterations constant, and again changed, again constant, again changed, dramatically changed, again maintain some constant steady route, again slight diversion. Like this it will go, and finally tuned the I think around by 70 number of iterations, the mean square error, there is no further deviations was noted. So like this is the way the convergence that XGBoost machine learning algorithm merged with which one optimization algorithm of Kokabura, the convergence plot was obtained. So I hope you understand the concept of this. So here further opening I views for the research. So we are using only one optimization algorithm. We use for nowadays hybridize the optimization algorithm like Kokabura connected with the Peacock, connected with like Arca, like that. And for another predator called like normally we say that Ferrari dog. Okay, like this we have to hybridize the optimization algorithm. We tune the further of our exploration like parameter fine tuning, initialization, evaluation, population management, operation, local search. So we do better exploration when we escape of the local search from these hybridization techniques, and we go for the global hybridization for the exploitation purpose, reduction of search space. Yes, m value, number of dimension, if you increase 100 your algorithm won't converge. So maximum most of the researchers they take a number of dimension 6 or 7, maybe sometimes 10 for rare. If you take more than this, the algorithm won't converge. There are many weakness present in the existing algorithms. So it is like a black box. We don't know which algorithm perform better. By conducting the experimental only we identify. Then for algorithm selection, then hyper heuristics, cooperative strategies, the new type of meta heuristic if you adopt, we will go for the exploration and exploitation. This is the area more important if you concentrate your algorithm and works well through AI direction for performing the better optimization values of your process parameters. So thank you so much. Professor? Hello, Professor? Sir, not audible. Professor, not audible. I think morning itself people are attending, I think so.
Same here, sir.
Yes, sir. Very good evening, sir.
Audio is not there.
Hello?
No audio from speaker. Yeah, now it is fine, sir. Yes, sir. Sir, how to select different optimization method as far as the data is concerned? Means which optimization method or hierarchy can you suggest?
Yes, sir. Thank you for your good question. Actually, I mentioned already, sir, none of the algorithm better than performance others, which means that no free lunch theorem. which means that the theorem says that, so it is like a black or a gray box. So we don't know which kind of algorithm performance better. But some algorithms exploration based, some algorithm exploitation based, some algorithm like that reverse concept. So in this situation, we use for hybridize the algorithm. For example, water cycle algorithm, one algorithm existing. Then for next algorithm, mouth flow optimization algorithm existing. Mouth flame optimization algorithm better in exploitation. Water circle algorithm better in exploration. So we merged here. Our one of our researcher merged here. He developed one algorithm called the water cycle mouth flame algorithm. That algorithm performed better. So in this sense, your problem, first of all, you frame your objective function. Okay, frame your objective function, decide that how many number of variables which are present in your equations, or maybe in terms of images means how many number of pixels present in this. If you are taking image in additive manufactured component, you always compare with some standard amount of which one images like Lena image, Barbara image, many images which are existing. So compared with the standard one, once if you validated, then you go for your additive manufacture work to produce the better results of your optimization values. So that problem based only we decide which algorithm is better, which algorithm is weaker. We analyze through this only, sir. Even for your good question, I am going to continue further in this. I think now visible. The author, in this author, once they performed, the author compared with the genetic algorithm, that is next PSO and GSA, he compared. Then he is telling that then compared with many more algorithm, okay, RSA and for AVOA, African vulture optimization techniques, whale optimization techniques, like that. The author test conducted by CEC 2021 test suite. Then he is telling that algorithm is sometimes good, sometimes bad. Mechanical component based tested. By the way, the experiments, simulation experiments are completed. And overall, your question based, you prepare first equation like this, or you take from standard machine design textbook, you prepare one algorithm, or already known algorithm based you prepare and do the simulation process. Once you trained, then you adopt for your additive manufacturing product. Definitely you will yield the good amount of result. I hope this answer more.
Yeah, thank you very much, Professor.
Thank you so much. Thank you so much.
Let me ask my, as far as my problem statement is concerned, I have prepared 3 composite material with the level of high, medium, and low, and I have optimized 6 3D printing machine parameters.
Okay.
So, can you suggest any optimization method so that I will go ahead?
Yes, sir. Just one more time, please repeat, sir, for gathering.
6 parameter I have I have selected for optimization.
6 parameter numerical parameters.
Yeah, means layer height, layer thickness, and
fine.
orientation and all.
Fine.
And I have prepared 3 materials, 3
Okay.
composite materials by varying their percentage.
Okay.
And in low, medium, and high.
Okay.
So, can you suggest any optimization method?
Yes,
for
sir.
this data?
Thank you. But my recommendation here, I don't. I am conveying here. Don't publish low, medium, high in single paper. My guru says always like that. Don't implement all your methodologies in single paper. You take one and do all 6 parameters. So I am showing you these many number of algorithms already existing.
Yeah.
Okay, sir. You can take a repeatal search algorithm. These are the latest algorithm. I am recommending, just if you have kindly note it down, because widely
repeatal search.
Yes, repeatal search algorithm. And the next one, honey badger algorithm. These are more strong in exploration and exploitation.
Okay, sir.
Okay, Professor. Next,
repeatal search and another one.
And the next one, honey badger.
Honey badger.
Honey badger. And the next one, Remora optimization algorithm.
Repeatal.
Repeatal. Next, which one? Honey badger. Next, Remora optimization algorithm. These algorithm, Remora. Just I am going to highlight.
Yeah.
For first low composite material, you adopt these three algorithms. Okay.
Yeah. Yes, sir.
Yes, sir. Once if you completed for next one, you see it, you maybe you trained, then you go for another set of algorithms. Okay. So in this sense, I am recommending these are that algorithms for a Komodo multiplier. Komodo, you know Komodo how it is killing, and for red fox. Professor, is it audible?
Yeah, yeah.
Okay, okay,
Yes,
sir.
sir.
Komodo, and for next red fox optimization algorithm, and another one Dean snake optimization algorithm.
Yeah.
Just 1 minute, I'll show you one example.
Means you want to tell me that I don't need to show low,
Okay.
medium, and high.
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Yes, this is our one work we carried out for the image processing. You can choose for this also snake algorithms. The snake, best snake, and for equal snakes are fighting. Snakes are having with matting. Like that, if you take snake variety of algorithm, better strong in which one, sir? A strong exploration and exploitation. We obtained good result. We applied in
Okay.
our research. Okay, sir. So like
Yes,
this
sir.
also, if you adopt, you will get it. If you are interested, personally you discuss means, please get my mobile number and maybe an mail ID to help you in this direction.
Please. Sure, sir. Sure. You
Thank you.
just drop your contact number. I will
Okay.
call you back, sir. Yes.
Okay. Thank you so much. Thank you,
Welcome,
Professor.
sir.
Mm.
Yeah.
Professor. Professor Rajashekhran, sir. Hello. Hello. Hello.
Hello, sir.
Madam. Good
Sir,
evening, ma'am.
I think some connectivity issue for Rajashekharan, sir. Hello, sir. Am I audible? Sir?
Can you hear me voice? Hello?
Yes, sir. Now you're audible.
Yes, ma'am.
Any other clarifications from participant side?
Okay, sir. Shall we wind up? Hello.
Sir, please share your contact details, sir.
Okay, sir.
Tamilarisan, sir. I think there were no more queries from the participant
Yes,
side, sir.
yes, ma'am. Yes, ma'am.
Yes, sir.
I think the statement visible. Hello.
Yes, sir.
Okay.
Visible, visible.
Okay.
Sir. Thank you, sir.
Ma'am, shall we close, ma'am? Hello.
Yes, sir. We will
Okay.
carry on with the assessment and feedback, sir.
Okay, ma'am.
You can end your meeting,
Okay.
sir.
Thank you.
Yes.
Thank you so much, ma'am.
Thanks a lot, sir.
Thank you, ma'am. Thank you, ma'am. Sir, thank you, Rajashekhran, sir. Thank you.
Sir, can
Thank
you
you.
stay 2 minutes? Sir, can you stay?
Yes, sir. Yes, sir. Yes, sir. No problem. Thank you all attendees.
Thank you, sir. Session was very, very nice, sir.
Thank you so much.
We all are expecting your valuable feedback. Dear participants, we all are expecting your valuable feedbacks. You can use our application ID. If you get any links in your through your mail, from that link also you can submit your feedbacks. So before assessment, I request Dr. Radhika Madam to give vote of thanks.
Thank you, sir. First of all, I would like to thank AACT ATAL for approving our FDP proposal. I also want to thank our Honorable Chairman, Dhanlakshmi Srinivasan College of Engineering and Technology, our respected Principal Sir, CEO Sir, for permitting us to use the resources inside our campus and supporting us throughout conduction of this online FDP. I also want to thank our Dean Academics, Dean Innovation, Dean Industry Affairs, and all the head of the departments, all the faculty members for their continuous support and encouragement. Also, my sincere thanks to all the resource person who have been accepting our request immediately when we have reached out them, and also spending your time and delivering wonderful sessions throughout last 5 days. I need to start from Dr. A.K. Lakshminarayan sir from SSN College, Dr. Chenchal Ghosh, Dr. Tamilarsan sir, thanks a lot sir. Dr. Ravi Varman from NIT Agartala, Dr. Elumalai sir, Dr. Sabarinathan, Dr. Milan D. Selvam, Dr. Joseph Daniel for their valuable delivery on the additive manufacturing and its sustainability reach. Last but not the least, I sincerely thank all the participants for their patience, extended support throughout the FTP. Thanks a lot.
Thank you, ma'am.
Thank you so much, ma'am.
Thank you, sir.
Thank you, sir. Sir, now we are going to start the assessment. You can leave, sir.
Sir,
Thank you,
sir.
sir.
Hello.
Any clarifications? Yes.
No,
yes,
no, no,
participant.
no clarification. You will just take some view from the participant side also. It is required.
Yes, yes, sir. Yes, yes.
Yeah, you can take from any 2 to 3.
Yes, please. Participants
sir.
are requested to share your experience towards FDP for the last 6 days. Your experience and valuable suggestions, please. We are waiting to hear that.
Sir, any other suggestions also from your side so that we can improve ourselves?
No, not. It is required when you will submit the files to the AICT. You will take one group photo as well as 2 to 3 participant site. They will just share their views about this FDP. Just collect it from.
For that, everyone need to turn on your cameras, no?
Yes, sir. Just.
Participants are requested to turn on your camera. Ma'am, can you take one screenshot? I'm also taking a screenshot here.
Yes, sir. Yes, sir.
Sir, how much time is for assessment?
Yes, sir. Within 5 to 8 minutes, it will be started.
Yeah,
wait
but
for 5
how much
minutes.
total time for the assessment?
Sir, everything will be informed, sir. Just
Okay.
please wait.
Okay, sir. Shall I wind up? Bye, sir.
Thank you, sir. Thank you very
Thank
much.
you, sir. Thank you all. Thank you. Thank you so much.
Sir, you will take one group photo.
Thank you, sir.
Sure, sir. Sure. The assessment link will be shared here. You can submit the assessment through Google Forms. There are 25 questions. You take 30 minutes. So before 7:15 or 7:30, you can submit the assessment. At 7:30, the link will be closed. So you can take extra 10 minutes from 7:15. So assessment, we have fixed the assessment time for 30 minutes. There are 25 questions. So maximum you can take 40 minutes.
Where it is said, sir? The
Is there
link?
It will be sent now, sir.
Okay.
Through the chat box, it will be sent.
So should we log in our ATAL portal or assessment?
No, sir, there are
is
two
shared
options.
here?
There are two options. One, through the ATAL portal, you can do your assessment. Another one, we can conduct assessment. We can enter your marks in the portal.
Okay, sir. We'll do ATAL. I guess that is more.
But you have to satisfy that attendance. The feedback link is not your attendance, sir. Separately, we have downloaded the history. Attendance
that is already completed, no?
Yes, sir. Yes, sir.
Sir,
That's
in
it.
ATAL
Both-
assessment link is there. I'm not getting that one.
No, sir, the assessment link will be shared now by myself.
No, it is not in the ATAL portal, no?
So 4 days before there was one option. Now I'm unable to find that
you are
option.
controlling from the coordinated side.
Yes, sir. From coordinate side.
And feedback also? Feedback format?
That feedback, did you get any feedback links from the ATAL website,
Just
sir?
I
To
will
your
check
mail
it.
ID? If you get feedback, you can give directly.
No mail ID will be there. In ATAL site, it will be there. Just I will check it out.
Sir, you can check, sir. Yes, sir. But we are having that option. After the participants giving the feedback, I can collect from the portal. But I cannot send through the ATAL portal.
Yes. I will check it out, sir. Just I
Yes,
will.
sir. I think they will send that link. If you get such link, just don't forget to give the feedback, sir. Now I will log in coordinator. I think from here I cannot initiate any feedback through the portal.
Sir, feedback is mentioned on the portal. I have checked it. At the feedback section, it is mentioned.
Yes. Whether it is asking the application ID or not, sir?
No, it is not asking.
Directly you can select the FDP and give the feedback, no?
Yeah.
Yes. I can get the response through the portal.
Yes.
Okay.
Yes. Here there is one coordinator login. Feedbacks. So here, yes, sir. So far I have received 13 feedbacks, sir. In the portal, I have received 13 feedbacks. Did you get? Oh, you didn't get in your mail, na? Through?
No, sir, it is not. I didn't get on the mail ID. It is.
But you can give through the portal.
Yeah.
Yes, through login we can able to find the link for a feedback.
So please log in your participant portal and give the feedback, sir.
Yes, sir. Kindly check Abhishek Kumar feedback has been received by you, sir. If you can check, sir, so it will be confirmed.
Yes. Can you tell the ID? Your name is not mentioned. ID is mentioned. Otherwise, I need to click each and every one and see. 320 such ID.
Okay, sir. Let me check the ID.
Title and ID alone visible here, sir.
So are you sharing the link in the in-call message, or are we get it on mail?
So through your through the portal, you have to give it, sir. That is a feedback section.
No, before assessment, should we give feedback or after?
No, sir. No, sir. That is not a matter. You can give feedback.
That's right. Actually, one of the feedback I just filled, for which the link is shared in the chat box.
So
But
that feedback taken by ourselves. Through the portal also you can give feedbacks. But
okay, so
feedback
that
is
will
not
be
your
the.
attendance.
Actually, I can't see the assessment link anywhere. Please help me out in this.
Now only I'm going to share the assessment link in the chat box, sir. Please wait for a moment.
Okay. So in chat box, right?
Now we are giving the feedback through the portal. That's why we are discussing about feedbacks. We didn't start the assessment. We are about to start the assessment, sir.
Rajashekaran sir.
Yes,
Hello.
ma'am.
Sir, let me clarify the participants. They got confused, I think so. Sir, all the participants, we don't have any assessment link in the portal, sir. We have only the feedback link which is given by the AACT in the portal. Assessment link we will be sharing now, that you need to submit through your chat box only. Only the overall FDP feedback link only will be available in the AACT portal. Don't get confused between the assessment link and the feedback link.
Okay, ma'am. Thank you
Sir,
for
is that clear,
clarification.
sir?
Yes, ma'am. Thank you so much for
Yeah,
clarification.
because assessment questions we didn't upload in the portal. Okay, we have prepared on our own. That link will be shared now. Sir, is that clear for everyone? Any queries, sir?
Feedback link is not there. Feedback for your.
Sir, feedback link, if it is available in the portal from the AACT, you submit, sir. Otherwise, no worries. We will give our feedback link for day 6. That also you can submit, which we'll be sharing now in the chat box. Sir?
Yeah, madam. In the
Now
ACT, that's the portal
sir,
side also I'm observing.
Every day you are getting one feedback link, no, sir.
That we are submitting.
That is developed by coordinators. That feedback link developed by the coordinators, sir.
Oh.
We are also collecting. We are collecting the feedbacks.
In the ATAL
through the portal, you can give feedback to the particular FDP.
Yes.
What you are attending.
That will be the overall feedback, sir.
Totally everyone will give 7 feedbacks.
Yes, that I'm telling you. That
which are developed by coordinators, and 7th one through the portal.
Yes, is the feedback name is Manufacturing and Industry 4.0?
Yes, sir. Yes, sir.
Yes.
Because our technology is under manufacturing and industry.
Okay, Manufacturing and Industry 4.0.
Yes, sir. Yes, sir.
Okay.
Yes.
Sir, assessment link is available through WhatsApp or?
No, sir. Chat box. I have shared through chat box. So you take 30 minutes to complete 25 questions. Many participants attended, having 100% attendance, attended full sessions. My sincere thanks to all. Participants, did you get the assessment link in the chat box?
Yes, sir.
Have you got it? Yes.
Sir, I request put the link on the group also, so that everyone can join.
Once again, I want to thank all participants for their patience. Thank you all. Before 7:15, just complete the assessment. I kindly request you to complete the assessment before 7:15. Thank you. Thank you all. Soon we will meet with another FTP. Thank you all. Thank you, madam.
Sir, Sir, may we leave now or should we wait for some?
Hello, sir. At 7:15, the meeting will be end. Those who submitted assessment, you can leave the meeting, sir. Hello.
Yes, sir.
If you have completed the assessment, you can leave, sir.
Okay,
Just I'm
thank you so
going to
much.
wait up to 7:15 to post the link in the chat box.
Okay, sir. Thank you so much.
Thank you.